Hello. Guys, can you put some message in the chat box? I just want to see you can ping me or not. Awesome. Cool. So now I think my screen should be working fine and good notes will be open here. Let me know if my screen is visible in the chat box. I can see. Yes, it is visible. Okay. So first thing, I'm starting with the Hive part, right? I want to explain this thing, the importance of the Hive. So far, like in the beginning, we have discussed about the Hadoop and the typical MapReduce coding, right? That why MapReduce or the distributed computation, distributed storages came into the picture. And one thing you would have definitely realized that talking about or coding everything in terms of the what do you say in terms of the typical map reduce, be it writing the map function and the reduce function, right, in typical Java and using those libraries is gonna be seriously very hard, right? So this was the main reason, I would say. And in the industry, right, when you move into the industry, what actually happens that not everybody will be having that good expertise on the programming language, be it the Java, be it the Python, be it Spark, or be it the Scala, right, and all these things. So this is the main reason that there was a necessity of some kind of framework which should allow the users, or which should allow any firm or any organization to work on these kind of jobs, or to write these kind of distributed computation applications in much more efficient way, where there is not so much training is required, right? Let's say there is someone, let's say as an organization, I'm working on typical, you can say map reduce code, right? Writing the map function and the reduce function, everything. So that needs definitely extra efforts, time, and the good expertise on the programming side, right? So in order to rectify all those things, there was a framework which came into the picture, right? Hive. So Hive, how it actually started, means as the necessity was clear that we want to build something where no extra efforts required in terms of the what you can say the programming and core, you can say the map reduce understanding and all these things. Let's say we have a simple use case that we have a huge chunk of data and we want to perform some aggregations. We want to calculate the simple, let's say count, or let's say we have an employee table and we want to count the employees for each department wise, right? So we can simply perform aggregation queries and things should be done for us, right? So that was the typical need at that time, and that is why this kind of framework, which is Hive, came into the picture. And Hive is basically known as the data warehousing service. Data warehousing, what does it actually mean? Where we try to store the structured data. So what is Hive here? Hive is simply what we can say, sorry, just a second, fountain pen. Okay, what is, wow. What happened to it? Just a second. Why does it happen? It was working fine. What accidentally happened to it? Just a second. I think the tip is something. Okay, yeah. It should be fine now. Cool. Let me just check the pen pressure, tip sharpness. Okay. Let me increase it a little bit. It's too much. Yes. So Hive is basically our data warehousing service, right? So data warehousing, why? Basically, we actually want to store our data, right, in the form of the meaningful information or the row column based kind of information, or pretty much structured. So whenever we will be having a structured, so there are 2-3 terminologies as well in the data, you can say data world as well. Data world as in data warehousing. So we have a data lake, we have a data warehouse, and we have basically data marts as well. So data lake is something where we store our completely raw data. It can be a structured, unstructured, semi-structured. But when we talk about the data warehouses, so in the data warehouses, we will be putting our structured data, as simple as that, right? So that is the reason, right? That is why we even call it Hive as a simple data warehousing service, right? And just a second. So in the data warehousing, this is about the Hive. Now I'll quickly jump onto the main part to discuss, like, which is like why Hive. So why Hive? And the reason is, first reason is simple to use. Simple to use, and Hive is basically built on top of Hadoop, right? So this is the main reason. Now in Hadoop, we know we have different components like we have HDFS, we have MapReduce, right? So HDFS is basically to store our data in the distributed fashion, and MapReduce to actually do the computation part. So the way Hive actually works, Hive is basically kind of framework or a kind of wrapper which has been provided on top of Hadoop. So first definitely Hadoop came, and then this kind of framework, where what will happen, it will actually point the HDFS, right? So in the typical Hadoop, what was happening, if you have written any MapReduce code, it will read the data from HDFS and will process it. So similarly, Hive is basically kind of SQL like framework, SQL, where whatever logic you have, whatever operation you want to do, you can just write your core logic in the form of SQL. And under the hood, what will happen, this Hive engine, it will try to parse your query, and it will convert it in simple MapReduce code by its own. So you can see that how much this effort has been reduced here. So if I simply talk about this point, right, it is a typical SQL kind of framework, right? So typical SQL kind of framework means whatever will be logic will be converted in MapReduce code. So now even you can feel that how useful this particular framework is in terms of the need, because here you are not investing your too much of time learning new programming language, again, be it Python, Java, Scala, or you are not investing too much of your time that how to optimize your MapReduce job, how to write that function, how to read the data from HDFS and writing it to somewhere, right? All these kind of things are completely rectified for you. So this Hive is simple. If I just draw very high level design, so here you can see you will be having your Hive framework, right? And this Hive, what it is doing, it is simply reading the data from here. You will be having, let's say, HDFS. So this is your HDFS box, right? And here your Hive engine. So what it will do, it will simply read data from HDFS, right? Read data, and then the next step will be simply convert SQL into MapReduce, right? So convert SQL into MapReduce, and this would be these intermediate step, you can say. Convert, I am just writing the high level overview, and after that what will be happening, the produce output or the result. As simple as that. This is the main purpose to have, right, the Hive. And now you can see how easily it can solve your use cases. So honestly speaking, in my experiences, I'll tell my practical experience as well. Being a data engineer, I have worked in like the Paytm as well. I have seen Paytm using Hive very extensively, right? I was part of central data engineering team. So whatever analytical data we had, be it the payments data, be it the flights data or payments bank data, whatever it was, we were trying to analyze with the help of Hive, right? So the data was getting generated on daily basis, and there we were also having the whole Cloudera environment set up. So the HDFS, the Hadoop cluster, and all these things were managed by the Cloudera environment itself. And whatever data we were getting, that data was first getting placed in the HDFS. That was the raw data. And then we were using Hive framework. So on Hive, how we were doing it, we were simply pointing our queries, or we were creating tables. Simply, you can understand it like a database is MySQL Postgres, where you will be having your database installed somewhere in your machine, right? And then you can create tables, you can do CRUD operation, insert, update, alter table, and all. So like in simple terms, you can understand Hive as a simple SQL kind of framework, but it doesn't work with the, you can say, it doesn't work like a transactional database. It doesn't work like a NoSQL database. It is a data warehousing service. So whenever somebody asks you, right, this might be a confusing statement as well. Let's say somebody asks you, can you name some databases in the big data? So you might answer that, okay, Hive is also a database. No, Hive is not a database. Hive is basically a framework or processing engine here itself, right? And its properties, like it works like a database. Like it will give you a feel that it is typically working like a database. It has its own where we like its own engine where we create tables. It will have its own meta store and all these things, but it doesn't work like a typical database. It is created just to support that typical map reduce execution. For that we had to invest a lot of time, and now it is pretty much easy. So that is about the Hive on a nutshell and high level overview. And apart from Paytm, there are again so many other companies which I know personally. So Amex is there, American Express is there, MasterCard is there, Grofers is there, right? And again, most of the companies are actually using it because so far this is the best one, right, which has been developed in terms of the you can say the like analytical queries. Okay, so this part is I hope pretty much clear. Can you just let me know in the chat box, yes or no, uh, that is like what it is, why it is actually used, right? Okay, I can see lots of yeses. Awesome. So now you have understood it, that what is map reduce substitution, Janki? Yes. So substitution, the correct word, because right, even if you open short description of map reduce, okay, I can see in the comments that folks are a little bit confused about the map reduce, right? All right, so let me quickly explain that part as well, if something which is not clear to you as of now, right? I'll give 5-10 minute brief about it. So right, we studied about Hadoop. Okay, so Hadoop basically had three components. First one was the simple HDFS. I hope HDFS is clear to you. This is the distributed file storage. Correct. Second part was the map reduce. Correct. This is for the processing. Right. Third was the yarn, and yarn was basically for the, you can say, resource manager. All right. So HDFS is pretty much easy to understand. Like we have local file systems, and when we talk about the big data, we need a distributed file system. Like we will be having a big cluster, where cluster, you can understand it like a combination of commodity hardwares, where each commodity hardware will have its own CPU and memory. And the way the Hadoop framework actually works, it works as a like master and slaves. Those slaves are basically those data nodes where our, let's say, GBs and terabytes of data will be stored in the partition manner. So let's say we had this kind of cluster, right? Simple cluster. Let's say we had this is our master, or we can say the name node, and this was our first data node, this was our second data node, and this was our third data node, right? So now in the local file system, like let's say you talk about your laptop. So here what happened on the desktop, you just pasted or you just copied, let's say 3 GB file. Already it will take time, 3 GB file in local laptop, right? So you stored it, and you can easily access it, right click it, probably open it with Word, Excel, whatever it is. But when we talk about the like terabytes of the data, we can understand that that is something which cannot be stored in the laptop, right? We need something, right? Obviously that can be stored. You need to scale your machine, and that will be a vertical scaling. So there are two concepts: horizontal scaling and vertical scaling. So in vertical scaling, you can increase the capacity of same machine. Let's say you have one single laptop, you can add extra RAM to it, you can add extra like disk space to it. That means you are scaling it vertically. But when we talk about the horizontal scalability, so horizontal scalable means like you are just adding more and more machines of the same configuration. You are not scaling one single machine, you are adding more and more machine. So let's say this was our 3-node cluster, 4-node cluster. So if I somehow add one more machine to it, so that means I am doing the horizontal scaling if I can add more machines. So this is kind of like horizontal scaling. And if I have one single machine, earlier it has, let's say, 4 GB RAM, and now I have added 4 GB more to it. That means I have increased its capacity, same the external disk as well. So in this case, what is happening? We are just doing the vertical scaling, right? So just remember these terms, because in the industry and the design rounds, this is something which will which you will face frequently, like what is horizontal scaling, vertical scaling. So if now I'm hoping that this answer is clear, what is vertical scaling and horizontal scaling. So I was talking about the map reduce part. So here, this is, let's say we had this kind of cluster, and we had, let's say 1 terabyte of data to be stored, right? And in the beginning, right, Sudhanshu would have talked about the block size, right? In the Hadoop, whatever data or in the HDFS we store, that will be splitted into blocks, right? And those blocks will be stored and replicated over the data nodes. So let's say your 1 TB file completely divided into thousands of blocks. So let's say B1 was stored here, B2 was stored here, B3 was stored here, B4 was here, and B5 was here. Okay, so that is how your data was stored. And now when we talk about the computation part, the map reduce. So I know I'm pretty sure you would have studied this part as well. You have given a self read about it. So let's talk about a typical use case, the word count problem in the Hadoop. So how that is happening? So let's say we have a book of, let's say, 1000 pages, and that book will contain simple plain text. So let's say there was a book, and here keywords written like good, sorry, bad, then good, and then okay, and in another line it was written, let's say, hi, then okay, then bad, right? And another line was, let's say, and no, and then good, right? And then high, right? So this is, let's say, part, this is your simple book where all this data is actually written, right? So this is the text data. This is the one sample. And remember, like, consider completely 1000 books of 1000 pages in your book, which will have this kind of text data. So how you are actually going to work on it, right? That is something, right? Even single-handedly, right? If you are trying to read that book and you want to compute, okay, what is the typical frequency of each word in that entire book, that will even take like hours, days, and months for you to calculate. And same will happen with the machine as well. So that is why we will have this distributed computation in picture of the map reduce. So let's say this is your entire 1 TB file, and this one part is, let's say, residing in one block B1. This one part is residing in another block B2, and this one part is residing in another block, which is B3. Okay, so now the problem use case is to count the frequency of each word which is present in that book, right? This is our problem statement. And now we know some part of our data is in B1 and B2 and B3, and these B1, B2, B3 are stored across the cluster like different data nodes. Okay, so the way we will be doing, or the way we will be solving this problem in a typical Hadoop or MapReduce program. So what we will try to do, we will try to write a map code, right? Or we can say simple map function, right? Map function. So see, I'll tell you why there was a need of this kind of distributed frameworks as well. So let's talk about your simple laptop, right? So in laptop, let's say you have written a Python code. Okay, Python code, and in your laptop there is a folder where you have stored your 500 MB of data. Let's say typical CSV file, right? .csv file you have stored. So in normal processing, right, with when we don't talk about the distributed computation, what happens in the normal processing, we try to send data to our code, right? Let's say you have your Python code, and when you execute it, let's say Python and the file name, let's say file name .py. So your Python code starts getting executed, and let's say in your code you are trying to read the data which is stored in your local machine or the CSV file. So what is happening? This Python code is trying to bring or trying to pull that data into itself, or in other ways, what we can say, we are trying to send our data to the code. This happens in the normal processing. But when we talk about the distributed computation, it happens in the reverse direction. So we will be writing our map and reduce functions or code. Okay. And here we had name node, right? We had multiple data nodes where the actual computation will be happening. So our data is stored here, B1, B2, and these data nodes will be having CPU part or computation part as well. They can do it. So here, what will happen as soon as we will fire a map reduce job? So this code will go to these blocks, right? So this same map function, because code is generic, code is something which will be calculating on every single part of our file which we want to calculate. So this map function will be sent to this node, same map function will be sent to this node, and same map function will be sent to this node. So that means whatever one single person was doing to calculate the frequency of each word in a file, now that task will be done by multiple instances of it, right? So this is a very simple practical as well. Let's say I have a book. If I give 200 pages to my friend, 200 pages to another friend, and another 200 pages, I will assign it to me, and we are individually counting the frequencies, right, of the words, and at the end we are combining those results. So this is the fast processing. That means things happen in the parallel. So that is how this typical map reduce code also works. So here in the map reduce, or sorry, the map function, what we will try to do, let's say we have this block and we will try to split it. So this, let's say the I'm calling whatever map code which is running on data node 1, I will be calling it as a M1 and M2 part and M3 part, although the code is completely same. So what this will do, it will try to read this input line and will generate a key value pair. Key value pair will be here, key will be our words, and here as a value we will assign 1 to it, right? Then good, then 1 to it, then okay, then we will assign 1 to it. Similarly here high will be 1, okay, and its value will be 1. Bad, right, its value will be 1. Similarly no, its value will be 1. Good, its value will be 1 here, and high, its value will be 1 here. So now you might be a little bit confused that good is present here as well, good is present here as well, and why the value is 1 here and why the value 1 is here. So this code is running on different nodes. So far this code has seen only one occurrence of this word good, right? That is why we are assigning value 1 to it, right? So individually this processing is happening. This is the map part. So the output of map code will be always key and value, right? So there will be a key and value will be the output of map function. Output of map. Now what will happen, since map of phase or map function has simply generated its intermediate output, now here will come the reduce part. So this reduce part, what it will do, it will read this intermediate input generated by the map function and will try to do the aggregation. So individual processing we have done, right? Now what we will try to do, we will try to just calculate, or we will try to combine the results of individual map functions. So let's say the result generated by map function M1 was R1, by this one result was R2, and by this one it was R3. So here what we will try to do, we will try to not summation, I'm just giving you the idea, R1, R2, R3. We are trying to just calculate it. Okay, so here it is all about counting the frequency. So during this map reduce phase, what will happen, there are other phases also involved, and those phases are nothing short and shuffle, right? Because map is something, it has generated the key value pairs. So reducer is a step where what will happen, let's say we have 5 reducers or 10 reducers, it will try to hold all such type of values where the keys are generating the same value, right? So what ultimately we can say, let's say this is our intermediate output which was getting generated, and we did a, so ultimately, right, this was the individual output, and now let's say you want to calculate the total frequency of bad. So you should know this part as well, you should know this part as well. So how this and this will be placed together if we do this sorting and then shuffling part as well, right? So in the sorting, what will happen, sorting and shuffling, that these keys, right, which were part of or which were generated by the intermediate output of different map functions. So intermediate processing, what it will do, it will simply pick these keys, it will generate that what is the hash value of it, because let's say we have 5 reducers, RD1, RD2, RD3, right? So these are our 5 or let's say 3 reducers, and we have, let's say, this bad as a key, and we will pass it into a hash function, right? And let's say the value generated is something 1. So let's say this RD1, its location is or let's say its ID is 0, its ID is 1, its ID is 2. So when we pass bad in the hash function, it generated 1. That means all the key values related to the bad word, right, which will be sent to this reducer, right, which is RD2. So in the RD2, the data will something look like this one, because we have sorted as well and we have shuffled as well. So this is the first value it has got, right? This one. This is the first value it has got, and this will be the second value. So here now 1, 1 will be sent to RD2. Similarly, let's say we passed good in the hash function, and it also generated the ID1. That means all the key values part which are related to word good will be sent to the reducer one itself, like where the reducer values this one, right? So good will be 1, 1 as well. Similarly, other these words and their corresponding values might get sent to other reducer as well, based on the value which is getting generated by the hash function. So let's say I have passed high as a hash function and it generated 1. That means for high related words, data will be sent to this reducer RD1, right? So in RD1, data will look like this one. High 1, 1, and this will be in RD1, right? So now you can see all those sort of like key values, right? In the after a map part generated the intermediate key value pairs, and that was accepted by the reducers as an input. They and even before that, what happened, there was a step of sorting and shuffling, because when we are supposed to count the frequencies of words, like whatever intermediate output was generated on different location, we had to place all the values which were mapped to same key at one place. In that case, we will be able to sum it up. If we are not doing this sort and shuffle phase, we will not be able to bring all common kind of data in one reducer, right? So that is why it was needed. So what will happen now, individual reducers will generate their output. So RD1 will generate, let's say, bad, 2, right? And RD1 generated good, 2. Similarly, RD2 generated high, 2, right? So this will be the result which will be written in your destination folder, which will be again a HDFS location, or it can be something else or downstream system as well. But now you might be interested to know that how many parts will be written in the output directory. So let's say you had 10 reducers working to aggregate your output. So individual reducer will write its own output in the destination. That is why your output will be also in the multi parts. So that is how this typical map reduce processing actually works. I know it could be a too much descriptive and more into detail, but you can let me know if like I made you like understand about this part, how this map reduce part actually works. Then I can move on to more onto the Hive part. I know right, the Hive was something. Cool. And don't worry guys, don't worry at all. We will be having our doubt session as well after the first part, right? Even if you have a simple doubt, again, technical map reduce, whatever it is, I will definitely explain in the doubt part, right? Which we will be having right in the later part. Cool. Now, okay, bad according to number of words, the number RD will be formed. So yeah, this is the part, right? Are we okay? I know there are lots of questions, so I think this will be good discussion in our doubt part, right? Where small doubts related to this map reduce part can be asked, and I can explain it. Then it will be pretty much easy, right? Agree, guys? Cool. Else, like, we will divert with our main agenda, which is Hive, right? So I'll definitely pick it up, right? You will get all your answers, not to worry about anything. Every simple doubt you have, everything you'll get your answers, nothing to worry about it. But I wanted to explain, right? Many people wanted to know what is this typical map reduce part and what it is actually, right? So that is why here the way it will simply work, that now you can understand that what kind of complexity it would require, right? If you want to write a simple map reduce code, right, using Java, Scala, you need a good expertise. So obviously everybody in the industry would have want a very simple, uh, right, simple kind of framework where everything is pretty much sorted, right? We are not spending too much of time in coding, just a simple SQL kind of framework and we are done, right? And that is how this Hive is focusing on. And again, just focus on this part, guys, which I explained how Hive actually will work. It will read data from the HDFS locations. Again, in the map reduce, what was happening, whatever data we stored in the HDFS, that was getting read. So Hive is nothing. Again, under the hood, it will completely change your SQL query in the map reduce code, right? So that conversion is being done by the Hive itself. You don't need to write your own code. And again, once that code is done, right, the code conversion map reduce, after that the whole processing will be intact the way it was getting executed in Hadoop, like the typical map reduce, same way it will be done here as well, right? So now let me explain more about the Hive architecture, and then we will be moving on to our main, you can say, the practical part, right, where you need to open your Hive console and you will be writing all those queries. And I will show you there that how that code is getting converted, and you will see that whole map reduce parts as well, right? So now let me move on to that part, right? So talking about the Hive architecture, right? So in the Hive architecture, there are multiple components as well. So multiple components, let me design it from here. So we will have our, let me know that if this is just a second. Let me share. Okay. So first thing, what we will be having here, we can have our this part, like that could be something which must be pretty much understanding the JDBC. I will explain what are these terminologies, right? Don't get worried about it, what I'm writing. JDBC, ODBC part. And then we will be having here simple CLIs. We can have like a Hive or thrift, right? And we can have web interface as well. Web interface. And then we will be having this big box. Want to improve my handwriting, right? So this is will be our core driver part, and here in the driver we will be having our parser, we will be having the planner, right? And we will be having the execution, and we will be having optimizer, we will be having optimizer, and downwards below we will be having our map reduce, right? And then on this lower level we will be having our HDFS, cool. And here we will be having our meta store. So I'm designing it first, right? I will explain every single thing. Like you will be pro in Hive, right? I'll make you interview ready. Like even somebody asks you that any black box of Hive, right? You will be able to answer it. That is my guarantee. So don't worry. And this is, so one thing interesting story I remember. So I was too much into like mugging up the things, right? In my initial days when I was data engineer, right? Like I was just starting with my data engineering journey. So that time what happened, I was once interviewing with Tokopedia. So if people don't know about the Tokopedia, it is e-commerce giant in Thailand, right? So that time what my intention was, if I just focus on the theoretical aspect of anything, I can crack any interview. Okay. So that was probably the wrong intention and probably a learning for everyone as well. I'm just sharing my practical experience, and that's how I don't want to run it as a typical class. I want to interact with you all as well, right? To know more about you, and you guys can know more about me. So what happened? I was just mugging up all the things, right? The typical fundamentals, the whole architecture diagram, the 100 and 200 interview questions, but I never focus on the practical aspects of anything, and that is exactly happened with me. So in Tokopedia, I cleared the 3 rounds, and the last round was with the vice president of, or you can say VP of data engineering at Tokopedia. And he simply asked me one very simple question of Hive to load, let's say, data from the HDFS location into a Hive table. And since I just already mugged up the things, I had no practical idea that how it is being done, right? And that is how like I minimize my chances to just crack that particular interview. So that is what something I want you guys to also understand the importance of practical part, right? So whatever we are discussing, that is fine, right? In terms of the theoretical aspect, it is important, but I would request you all to focus more on the practical part when we will be talking about it, right? So first, let me talk about the individual components of our architecture, right? So here you can see this JDBC part, ODBC, CLI, Thrift, web interface, right? So client here, or you can say this JDBC, Thrift, or if any of you, let's say, have worked with the databases, right? And when you are actually try to connect with any databases practically, practically, it is like when you try to connect with any database programmatically, then you need some connectors, right? So those connectors will be helping you or your program, right? It will have those kind of dependency or the programs installed to it, right? Which will help you to make a connection to any database, right? So similarly, what happened, let's say there we have our Hive, right? This is our, let's say, Hive service which is running, right? And this is our one program. Moving forward, when we will be doing exercises on Spark, so let's say this is our Spark program. So Spark can also make a connection to Hive, and this, let's say, want to make a connection to Hive, or let's say even this is a simple Python program, and with the help of that you want to make a connection to Hive, right? So what you need some kind of connectors which can help your program to make a connection to Hive server or wherever the Hive is running. So for that, we need this JDBC and ODBC sort of connectors, right? And this is something which is available on the official documentation pages. And even if you type, let's say, Hive JDBC connectors, you will see those files which you can download and use while making connection to Hive, right? So this is the first part, right? So this is the main core, right? Which I'm talking about, this Hive section, right? So this is, you can say, the whole core of Hive. This is the also external part, right? This part which I'm talking about, and this is also somehow the external part of it, right? So here, what is happening, right? Let's say we want to interact with Hive, or we want to run queries on Hive, right? So there could be multiple ways. Again, let's say you can open a terminal, right? So terminal, let's say you have the in your Cloudera VM, right? You can open your terminal or Ubuntu or Linux terminal from there. Since Hive and other things are already installed in your Cloudera VM, you can even try it right now. Just type Hive there, right? In your terminal, type Hive and hit enter. What will happen? One like Hive shell will be open for you, right? So that is something like CLI, command line interface. Command line interface means this is also one mode or one way to interact with your Hive engine, right? Let's say whatever command you want to execute on the Hive, so that command you can fire from the command line itself. So for that, we have CLI as one of the communication medium or one of the medium to interact with Hive. So this is number one. And JDBC, ODBC connectors will work along with the Thrift. So JDBC is just a kind of a wrapper on top of like the basically a connector, and this service needs to be up, or this service needs to be kept on running if we want to make connection to the Hive or cluster or Hive engine, right? So this is a backend daemon service which is pretty much required. You don't need to focus on that much to understand, but always focus on this JDBC connection. Whenever somebody asks that how you will make a connection to Hive engine programmatically, then you need to say that yes, we would need the JDBC connectors to make a connection to it, right? So this is the second mode to interact with the Hive engine, and this is the third mode. So in your Cloudera environment, when you will open Hive, right? So when you will open Hive, there you will see the option of Hive, right? In the drop down, there will be an option of Hive. So when you will select it, then one query interface will be open for you where you can type the queries, and those will be directly running as a Hive queries. So this is the third ways or third mode as well. So all these three things which I talked about, these are our clients. Clients means the source or any point which is firing queries or which is trying to interact with the Hive engine. So we can interact or we can execute our query on Hive using CLI, right? Writing whole query on a Hive shell, or programmatically as well. And third can be using web interfaces, Hive or any other, right? So this is the main clients part. Now talking about the Hive part, right? This is something which is very much important to understand, that what are different components of it and how Hive actually works, right? So first I will talk about this driver program. So this is the main box, or you can say main typical part of this whole Hive, right? The upper box, right? And inside that other smaller services will also be running, right? But before that, I can see a few messages in the chat box. Thrift, can you elaborate? Thrift is not clear. Does JDBC means? So okay, so talking about Thrift in more detail, right? So see, what will happen, that let's say this is our Hive, right? So this will be installed on somewhere, right? Hive server, or you can say Hadoop cluster will be there, right? And there what you will be doing, you will install your Hive as well. So when you will install Hive, so you will start Hive as a service as well. Okay. So that service or that backends or the daemon service, right, which actually keeps on running our Hive engine, is actually known as the Thrift server. This is a name just given to it, right? Don't get confused. So that is the like backend daemon service which will keep executing our Hive engine, or it will help Hive to spin up its Hive engine, whatever terminologies you want to use, right? It will help Hive to kept on running, right? So for that one, Thrift is needed. Or in a simpler words, if you want to understand, right, let's say from your program, let's say Python program, you want to make a connection to any remote server. So for that, you would need the host IP or the server IP, then the port number, right? And all these things, and then you will be able to make a connection to it. So similarly, let's say Hive was installed somewhere on any remote Hadoop cluster. So you would need this, right? First, you need to make sure that Thrift servers is running, because this will be the endpoint, or this will be the backend daemon service which will listening to those incoming requests which are coming to Hive server in order to interact with the Hive engine. So this backend service is responsible for that, right? So this is the high level overview you can understand about the Thrift, why it is needed. If whenever, let's say, you are trying to work on Hive and you are not able to make a connection to it, and let's say your Hive on your Linux or machine, you have typed Hive and your Hive shell is not getting open, that means somehow your Thrift service might be down, right? Or wherever your Hadoop is installed, that entire Hadoop cluster might get down, right? So that is the need of Thrift, right? And that is why this Thrift service is being used, backend daemon service, which will keep on listening to all those incoming requests which are coming to Hive engine for any kind of processing, right? So that's how it will be working, and that is the main purpose to have it. I hope now it should be clear. Is it clear, right? Cool. Awesome. To make the Hive connection alive, Thrift is a background. Yes. So yes, until unless if your Thrift is not working, that means you won't be able to make a connection to Hive programmatically, right? There, that Thrift is something, again, I'm repeating this part. This backend daemon service is something, right? So that is something which will help you to make a connection to the Hive engine programmatically. So Thrift will be that backend daemon service which will keep on listening to those services which are coming from that JDBC and ODBC. Okay. Cool. So this is, I hope now you guys understood it. Now I'll come back to our architecture part. So I was talking about the driver. So here driver, how it actually works, it is like, you can say, main member of this whole, or you can say the main person which is taking care of all this Hive setup and all these small daemon processes which are running under this box. So it is like a controller which receives Hive query statement. And guys, when we talk about Hive and when we talk about other databases, so in databases we call it SQL, right? Structured query language. But when we talk about Hive, then we call it HQL. So HQL means Hive query language. So remember these terms. So driver is something which will accept those kind of incoming request, or like after Thrift servers, if I'm talking about the programmatic connection, so those requests will be captured by the driver, and from there it will try to analyze it. This driver starts the execution of the statement by creating different session, right? So let's say one request was received, right? So let me go down. So request was request one was sent, right, to perform something. Request one is here, so that will go to driver. So again, driver is something, right, you can say a gatekeeper or anyone, right? The main member or main person which is allocating sessions for you, because every request will come into a different session. Okay, multiple sessions will get created on a Hive engine. So who will manage all those kind of sessions to open it, and then once the execution is done, then to close those sessions? So that will be done by driver. So I'll keep on writing that what is the responsibilities of driver. First, it acts like a controller for HQL statements, right? Whatever incoming queries will be coming. And the second basically creates sessions for query, right? So this is the second part. And once, like, let's say your session part and all these things like done for you, then your query is actually eligible. There will be multiple steps involved in between. I will talk about it when I will discuss these steps, right? But driver has something, let's say it has accepted the query and now it has opened a session. After that, it will maintain everything, the entire life cycle, like maintain life cycle of query, right? Starting from its execution, what, and converting and helping the engine basically to convert this code from HQL to typical map reduce, right, of HQL, right? So this kind of thing will be done, and driver stores the necessary metadata as well to generate, right, or whatever is actually needed in terms of the execution part. So whatever metadata you actually need, right? So everything will be done by your driver itself, because driver is something which will know all those kind of things that, okay, in particular Hive table, let's say we want to load data from HDFS, then what will be the location and what where these kind of files are located in the HDFS. So that kind of metadata, right? So it will have maintain information, maintain metadata for execution, maintain metadata for execution, right? So once this part is done, so like when I was talking about the HQL part, that once you fire your query, it will be converted into the map reduce code by default. So who was actually owning that part and doing this thing? It was the driver itself. So it maintained like it worked like a controller, created sessions for your Hive queries and maintained the whole life cycle of your query, then maintaining metadata for the execution, and also whatever results will be generated by the reducers, right? So collect the results as well, because this driver program will be something like whatever reducers will be working behind the scenes, they will produce the output and they will send it to the driver, and driver will be displaying that output to our screen if it is a web interface or it is a CLI. So collect output and display. Cool. So I hope for the driver part things are understood. Let me quickly check. All right. So driver part is clear, I hope. Let me again quickly check. Yes. All right. So driver, again, just understand it like a master, for not just related with the Hadoop master and all these things, related with the master who is taking care of that whole Hive engine part of things, right? So this is the role of driver. Now we will be talking about the since the this part is done, sorry, this driver part is done, then I'll quickly talk about this thing. What I would say, if we talk about simple SQLs, right? So in SQLs, I will write a simple step, right? Let's say you have a SQL query. What will happen? First, let's say you have written your SQL, syntax check will be happening, or you can say it as a parsing. Syntax and semantics checks will be happening, right? Once the semantics and syntax are done, then the execution plan will be created, that how this query will be executed. So multiple execution plans will be there. So execution plan will be there, and after that what will be happening, then optimization will come into the picture, right? And then the whole processing part. So this is a typically like our SQL part also works, right? In right, when we talk about the databases. So similar to that line, right, we have multiple components in our Hive engine as well, right? So first we talked about the driver part, and after that what we will be having, I can first start with the not meta store, but I will first talk about the executions related thing, and then I will explain more about the meta store, because that is something where lots of folks get confused that what is this meta store and like why it is eventually needed. So I will talk about it. But now since we have understand the driver, so here as an incoming request, any HQL, right, simple again a SQL type of query will come into the picture. So after that what will happen, the compilation will be happening, right? So compilation, you can say compilation and parsing will be pretty much equivalent. So let me write it here, that what will be happening next, the parsing or the whole compilation part. So in this compilation part, what will happening, it performs the compilation for HQL, whatever we have. So compilation is very simple to understand the basic fundamental of programming languages as well, where let's say you have important some libraries, whatever syntax or code you have written, whether it is correct or not syntactically and semantics, everything is correct or not, the linking part and all those things, right, typically happens in the compilation. So this converts the query to the execution plan. So first let's say simple syntax check, we can say the syntax check in the compilation, then it will work or maintaining or creating the execution plan. This will be the job of compiler, right? Once the execution plan is created, and right, it also contains steps needed to perform by the map reduce as well, right? So let's say execution plan is clear to you. So when we would have written our Hive query statement, right, there would be multiple functions and multiple steps which were involved to it, right? So the steps which are required to get the output, that will be something which will be generated by this compilation and the parser. So steps to get the output, right? So this is another responsibility of it. And after that, right, so once that semantics part is done, once the syntax part is done, once the execution plan is done, right? So after doing all these things, means this is, you can say, the overall performance or the overall responsibility of our like compiler in the Hive. So as soon as it finds any syntax related error, like your query will not start getting executed, or let's say as soon as, let's say, even you have pointed or you have mentioned any wrong HDFS location in your Hive query, or you have used wrong syntax for the you can say the create table, insert, or any kind of select statement. In that case, all those statements will be aborted, because that kind of syntax and semantics check was applied by the compiler. Then the execution plans, multiple execution plans can be created. So let's say you have written after that group by, then some sub query and multiple based on the you can say, so based on the like the components or the functions we have used in the Hive query statement, multiple execution plans can be created, right? And what will be the best to execute, that will be solved by the optimizer or the engine itself, which will try to pick the best execution plan, which is pretty much cheaper in terms of the cost, and that cost is something which is basically the execution time, right? But here these were the overall responsibilities and error part as well. Let me write the raise compile time errors. So the compiler part is done. Now we will talk about the executor, right? And after that, we will talk about the optimizer. And that is how, like, you will get to know that whole part, right? So we have so far talked about the clients, the driver, the parser, right? Or parser or planner, right? You can combine them together. Whatever few steps which I included, those were coming from the planner as well. So parsing, syntax, semantics, all these things were done. And then the planning or basically kind of responsibility which these two are doing together, and in combine, you can call them the compilation step or part of compilation step, like preparing that execution plan. And the executor or the execution, right, what it actually means, let me write it. Execution, right? So in execution and optimizer, so one compilation and optimization part will be done. The executor executes the tasks, right? So tasks, how should I actually tell you the task? I can again go back to that map reduce code which I was talking about. So here we talked about the map codes, right? So let's say one block right? One block will be assigned to one map code, and the smallest execution unit, right, in map reduce code is actually known as task. So let's say your input 1 TB file was divided into 1000 blocks. So ultimately 1000 tasks will be created in parallel for the execution. Okay, so that is a simple meaning of task. So we have executor here, and before that even we should just a second, we should talk about the optimizer part. So planning, compilation and planning was done. Then the optimizer will come into the picture, which will try to optimize the execution plans, right? Or whatever multiple, let's say there was one input query which we have sent to engine, and three different plans were created, right? E1, E2, and E3. So this plan is nothing, right? If you are getting confused that what is plan, so I can explain it with a simple example. Let's say simple select star from, right, table 1, where let's say after that we are doing where some columns, then group by, then some columns, and after that let's say one more sub query, right? So in SQL, right, these are the operators, right? We have different operators like from, or keywords, you can say where, group by, and all these things. So these are the operators here, right? So here optimizer, what it will try to do, it will try to see that let's say if I do, so here we can see the use of where and we group by are getting used together. So this executor or the, sorry, in the compilation steps, when the execution plan will be created, it will try to check multiple permutation and combination to execute this query. Because what can be done here, group by can be executed before where clause, right? I'm just giving you example, simple example for you to understand it. And similarly, where clause can be executed by group by after after group by. Sorry. So here what is happening, group by can be executed before where clause, and in this execution plan E2, so this is E1, this is E2. So here what will happen, where clause is getting executed before group by. So these are the two plans. Now this optimizer, what it will try to do, it will try to do the it will try to calculate the cost, right? So cost is nothing, basically that if I go ahead with this plan, then how much data I need to scan, how much data I need to store in memory, how much data I need to store in external disk, right? And what will be the total computation time required, right? So cost 1 will be calculated. Similarly, cost 2 will be calculated by this execution plan. If I go with this kind of execution plan, then what will be the cost? Now let's say there are multiple execution plans. So whatever execution plan is giving the minimum cost in terms of the runtime and other things, right, or the resource as well, that execution plan will be picked for the ultimate execution or the last execution part, right? So this optimizer, what it will do, compare execution plans, right? Calculate cost, right? And this is like overall we can say these are the two most important part of this optimization part. And here, like whatever is the execution plan, that is nothing more like a DAG, you can say as well. So execution plan, right, whatever it will have execution plan DAG, right? Let's say we had 3-4 execution plans, so one DAG will be picked. Like that pickup is also part of this, like which execution plan this optimizer has picked. So after the comparison of the execution plan, the calculation of cost will be done. Then the execution plan, which is right, the execution plan, or you can say DAG, will be picked. And after that, what will be happening? it aggregates the transformations together, such as converting a pipeline of joins to a single join. And then for better performance, what it can do, it can place where clause before any kind of joins, right? And similarly, group bys before any kind of join, so that the data size can be reduced, right? All those kind of permutation and combination that will be checked, right? So everything related to the optimization tactics. And moving forward, we will be studying more advanced concept of the partitioning and bucketing and the map side join, right? So sorted merge type of join. So everything, right? These properties and those kind of execution plan, right, will be taken care by the optimizer, right? So here, like try to place or combine transformations together. Cool. So this is the main responsibilities of the optimization part. Okay. Can you elaborate the planning part? It is very similar to SQL engine. Your voice is okay. So I can see one. I will definitely explain a DAG, right? Quickly, I will explain the DAG part, right? And I just want to clear one thing. I see one question like, can you elaborate the planning part? So are you clear with the planning part, which I was talking about, the execution E1, E2, that where I'm placing the group by before where? So that part is clear or not still? Okay, okay. All right, so I can see, all right, I think looks like not clear. All right. So, okay. So I think again, folks are pretty much confused with the execution plan and what is happening. So again, let me quickly reiterate on it. I'll do it. And then again, I will reiterate on those parts, right? What do you say, the components, right? To summarize, right? I will summarize everything. Don't worry. You can take a note of it, that what is the summary part, but I'll quickly explain the execution plan, right? So I will explain this execution plans, and I know the DAG as well, right? So DAG, I will simply explain this part. So in terms of the SQL, right, I will explain the execution plan in terms of the SQL, because I'm talking about the Hive here. So I will explain it with a simple example, right? I won't complicate it for you to understand. So let's say select star from employee table, right? Where I'm writing this part, right? Where, let's say, location like equals to India. And after that, what we need to do, we need to do the group by, right? Group by, let's say, department. Right? Let's say that's how we want to group by. So here we won't be doing a select star. What the problem use case is, just get this part, like in India office location, what is the count of employees per department wise, right? So department comma count star, right? This is something we want to calculate. So now this is just treat it like a HQL, or this is your Hive query, right? Now this query will be received by the Hive engine, right? This is the input query which is coming here. So Hive engine has received this query. After that, what was our step? It will do the compilation, or you can say the planning part. Planning, and here also the syntax, everything will be done, right? So once that part is done, right? So here the execution plans like E1, and E2 will be created, and that will be sent to this part, the optimizer. Right here, only execution plans will get created, right? And after that, the execution. So here, let's say, okay. So now I will explain that where this optimizer is much more useful. Like just hold on, right? If you are getting confused. So Hive, then we have created the execution plan, then it was sent to optimizer, then the actual execution happened. So I was talking about this query part, right? So select star from employee where location equals to India and group by. Now think from the engine perspective. So see, let's say if I have an employee table, right? Employee table where I have in the employee table, I have at least 200K records. Okay. So according to problem statement, what does it say? We need to only do this exercise for the employees which are located in India. So the first execution plan, what it can do, it will say that I will first apply the where clause, and after that I will do the group by clause. This is definitely a one potential option or not. Agree? This can be done in one way. Now we will talk about the E2 part, execution plan 2, right? Since group by, what we can do, we can ultimately do the first group by and then apply the where clause. That can be also one possible plan, right? I'm just giving a very simple examples for you to understand that you don't get confused why it is like that. Okay, that can be also be done. This is, so first let's say I will do a where clause like filtering, and then we'll be doing a group by, and then first I will do in the execution plan 2, I will do a group by, and then we'll do a where clause or the filtering operation. Correct? So now can you tell me which one will take less time? What will be like, whether let's say the cost is C1 for this one and C2 for this one. So what will happen? C1 greater than C2 or C1 less than C2? C1 is better, right? Any answer like why C1 is better? Reduction of data, filters, filtering. Exactly. Yes. So this is the main important part to understand, and that is how our all the SQL engines or the any kind of query engines, right? Those are present in the market. And even I will talk about the Spark as well, because Spark has also support for the Spark SQL. So its engine also support this kind of optimization. So you understand in that well, if we don't have these kind of optimizers in place, we won't be able to, like most of the time, right? We won't be able to write our queries in such a way that it is highly optimized, right? So sometimes we leave this responsibility to the execution engine itself, right? Or the, let's say, Hive or SQL we are using, that they will optimize this plan. If they are not doing it, then we will always, or let's say our queries will always take tons of time to get executed. So at least now, just let me know in the chat box if you guys are clear with the execution plan and what is, why we call it as an execution plan. So this is a very simple one single liner query. Now imagine a one page query where like so many joins or so many where clause and all these things are getting used. So you can even imagine how complex that execution plan will get created and how difficult it will be for that kind of execution engine to figure out that which one is the best one. Cool. Awesome. So now the execution plan is clear. So we can again switch back to the optimizer part. So the execution plans were created. Okay. But optimizer, what it was doing, it will first, definitely it will try to pick the most minimal or the any execution plan which will have the minimal cost associated to it, right? This is the first responsibility. And after that, it will try to apply further optimizations as well. Further optimizations, I will probably explain it in terms of the, you can say in terms of the, let's say, how should I explain it? So I was talking about the typical word count problem, right? So in the typical word count problem, what we did, first, we read the input, and after that we did like flat map. I will tell you what was that. Don't get confused with that, right? So flat map, in this function, we passed this line one. Line one was, let's say, high, comma, bad, comma, good, right? So this line one will be passed into this flat map function. So flat map function, what it does, it always create a one to many kind of mapping, one to many. So here we passed this thing, right? And in the flat map function, so what it will do, it will basically generate this kind of like here in the flat map function, we can basically split our line based on the comma separator. So what it will do, it will generate the separated words for us, right? Let's say the sort of this kind of list, let's say high and then bad, right? And then good. Okay. So this will generate, and after that we will pass this, let's say R1 intermediate result to map function. So in this map function, we are passing this intermediate list because we have sliced words. And now I need to create this word comma one sort of value. So the output of this map function will be something like this, right? Which will be something like this: high, one, and then bad, one, and good equals to one, right? So see, ultimately, we can have other operations as well. We can have joins as well, right? This is a word count problem, but when we talk about typical data sets, let's say we are reading 2-3 CSV data sets in the Spark, or we are reading 2-3 data sets in Hive, right? We created 2-3 tables, so we can join them, right? We can perform the group by operations on top of it, right? All these things can be done, right? Now, the responsibility of optimizer is to figure out and to try to place all these kinds of transformations together where shuffling is not happening, right? So shuffling as in, right, let's say the way I have written my application. So first what I did the flat map part, right? And then after that, I did some join operation, right? And then after that, I'm doing some map operation. Or let's say after that, I'm doing any filter operation. Okay. So these are, I have written my code or my query, right, in such a way so that in this sequence, these things are getting used, like the filter map, then join, then map, and the filter. So these are the transformations. In Hive also, these will be known as transformation, and even in the Spark, we will have these things as a transformations. Right. So randomly, so if I go ahead with this thing, right, let's say, although we have like different executions plan and we have the cost as well. Okay. But in that case, within the program and within the code itself, the optimizer will try to place these transformation in such a way so that the data size can be reduced and the less data shuffling is also involved there. So it can scan the whole, you can say it will scan whole code, right, or the transformations we have written. Okay. So it will, after that, it will try to create a DAG. So let's say these were the 4 operations we written, right? 1, 2, 3, 4. So here each transformation can be read as one particular you can say the node here. So this is node 1, right? After that, it was connected with join. This is node 2, and after that, it was connected to this one, let's say map, and after that, it was connected with the last one. So DAG is nothing. It is known as the directed acyclic graph, means a kind of graph where cycle is not getting created, and it will have direction as well. So these arrows are actually telling you the direction, right? From where your execution is started and on which particular transformation, right, your execution is getting ended, right? So for us, things started with flat map. So node, like the transformation, right, flat map is our node 1, then the join, let's say, right, and then the map, right, and then let's say we have this kind of thing, the filter. Okay, so we always know filter or where clause or these things are a kind of important transformation if they are somehow in this DAG, right? If they are somehow can be placed on the top, right? So our execution plan will be much more optimized, right? And not only this one, all such type of transformations which can be placed together in sequence, so that not too much data shuffling is happening. So that will be the sort of responsibility which optimizer will be doing. So in that case, ultimately how this DAG can be flipped or can be created. So this will be the filter. First, let's say filter our data so that the data size is getting reduced. Then apply the flat map, then do the map part, right? And after that, do the joining part, right? So here, if we talk about these three transformations together, these transformation on can be done linearly in each task, right? So this is one execution segment is happening, right? So now let's say our data set, which was block B1. And as I said, let's say whatever program we have written, that is our map program, and then the reducer will be happening part, right? So this is our block B1, and it will be in our map code. And in the map code, these are the executional steps. So now you can understand, first filtration happened, after that linearly flat map happened, and then the mapping happened. So for one single block, these operations can be performed linearly within that data set, right? For these kind of linear operations, you don't need to bring data from other nodes as well to one single place and then perform it. So that is the data shuffling. When we talk about the complex and the costly operations like group by and the join operation, the reduce by tree, and all these operations, so these are the costly, and these are the operations where you can see the lots of data shuffling will be required. And why data shuffling? So let's say this is our cluster, right? So this is the part, this is our node D1 and this is D2. So here what is going to happen, let's say you wanted to, since data is distributed, you want to join two data sets, right? Data sets D1 and D2 for an example. And for data set D1, let's say we had block B1 and block for data set D1, block B1 is stored here and block B2 is stored here. Again, I'm repeating, these two are B1 and B2 for the data set D1, right? Similarly, let's say for data set D2, right, there its block can be, let's say B3, which is stored on D2, and its another block is something which is stored on another block, which is B4, which is stored on this one. So now let's say you want to perform the join operation. So join is something which will be happening on particular keys. So let's say you don't have the entire data for all such type of keys where values are same at one single node, then you won't be able to perform the join operation. And similarly, you won't be able to perform the group by operation as well. Okay, so if that is the case, so what will happen? In that case, we will not be able to perform the join operation. We need to shuffle the data from this node to this node, so that all the common keys can come to one place, right? So that's how the join operation and group by operation will need that kind of data shuffling. But here, these operations can be performed linearly without even shuffling the data. So linearly, what does it mean? Whatever individual data have this particular map function or the task have, it can simply perform these linear operation on top of that. So this is also another kind of optimization, because we have avoided too much of data shuffling. So this part is clear. This part is clear. Okay. Yes, data will be shifted to some other node. Correct. So your point is definitely correct here. Data, what will happen when we talk about these costly operations, and now at this moment, you don't need to worry about it. When we will be extensively working on the Spark, right? When we will be discussing the transformation actions in depth, right? Those things will be clarified, and we will definitely talk about how this thing is actually happening, right? The data shuffle done within containers now? No. So data shuffling will not be done over the containers, right? So that is why I'm saying, so let's say this is one part was stored here, this one, right? The block 1 was stored here and block 2 was stored here. So your map is something, map code or the task is something which is running on individual node, right? And every individual node knows that the task which is getting executed at this moment, it is supposed to perform the join operation. And join, it will try to see, if you simply consider the SQL operation, how will you be able to do the inner join and outer join? So you need to match the keys, right? And in the distributed data systems, some of the data will be stored on data node 1, some of the data will be stored on data node 2, right? So obviously you need to bring those common keys together at one place. And obviously, so some data will be shuffled from this node to this node, and some data will be shuffled from this node to this node based on the hash values of the keys, right? So that is something, that is how this will be taken care. Will the data will shift permanently or temporarily just for query execution? So yes, that is also a good point to call out, right? So that is something so in yarn architecture, so see, your point is, see, container join, here there are two aspects: how join is happening and how join is getting done. So operations will be done in the containers. Your point is completely correct. But what I'm trying to explain here, that data shuffling is something which will be happening from node 1 to node 2. And after this one, we'll definitely take a quick break. Let me just clarify this one. I don't want you guys to be in the confusion that what is. So see, right, let's say this is the data node 1, this is the data node 2. Okay, and I have a employee table, right? So employee table, there, let's say column name, let's say the ID, right? And then something, let's say salary. So this is a smaller block B1 of employee data, and this here block B2 will be the employee data, right? So just 5 minutes more, when then we will have a break. I just want to clarify it. So ID, so let's say ID 1, value 1 is there and its salary is 1000. So similarly 2 is here and it is let's say 2000. And now let's say 1 is again and it is 5000. So similarly here, let's say ID 1 is here and it is 10,000. Both the blocks of different nodes. Yes, the both this B1 and B2 will always be present on their respective data nodes. So even the join operation is happening, data will be shuffled for that particular process itself. Here, please note this point that data is not going to be permanently moved from D1 to D2 data node. It is just the whatever resources we had, it tried to pull the data one place, try to process it, right? And try to do the join part, and then task is done. Your original data is not getting impacted here. Okay. So let's say another ID was here 1, and then again, let's say 3, and salary was 500, and then 1, right? Then the 2000. Now, this was the B1 part, and this was the B2 part. So here, let's say we had department table as well. So for the department table, let's say we had a block B3, which is stored in this data node D1 and this data node D2. Okay. So B3, we had, let's say, department ID, department, let's say name, and the ID, like the employee ID, which is working for. So similarly on data node D2, B4 is also there. So department name and the ID. Okay. So department name here, what is, let's say the finance, right? And ID1, and again, let's say what you say, the IT department, let's say 2, and here it's some chunk was here. So department, let's say name was, let's say the operations department, and it has ID 3. Okay. So now you can say these ID values, few values are here and few values are here as well. So here in the finance part, you can see this value, and you can see the value 3 here as well. So again, I'm calling out this part. This is a separate data node. This is a separate data node, right? Now, let's say you have performed a join operation on employee table, right? And the department table. So for that, what you have used from the employee data, you have used ID column for the joining, and from the department table, you have used the ID column for the joining, right? So now let's say you have performed the join operation. So in this node, right, one map task is running, and that map task knows that I need to join this data set, right? I need to join this data set employee with the department. Same map function is running here as well. Both of these having a same logic, and they know what they actually need to do here. Okay. So what will happen here? After that, employee department. Now here you understand this part, that how this entire joining part and all these things will be done. So whatever number of, you can say, when we talk about the yarn, right? So yarn in the typical map reduce processing, right? What will be happening? We will be having the containers, right? So this is the container 1, this is the container 2, right? So this is our yarn, which is our resource manager. So obviously the processing is something which will happening in the containers, right? Obviously C3. Okay. So now what this container wants, this container wants all such type of right records which are having the same keys. Then you will be able to perform one single partition join on this container C1. So that is why I was saying, now all the records which are having this value be let's say ID1, right, from the employee table will be coming to this one. So let's say employee part 1 data, right? It will have 1, 1000, 1, 5000, and 1, 2000. So this data has come from the part 1, and similarly from the department table, this record will be get picked, because here the ID value of 1, and how it was getting determined, we use ID column for the join operation. So whatever column will be used for the joining operation, hash will be calculated on that key values, right? So based on that hash value, it will be decided that on which particular reducer or the container that particular record needs to go, right? So this is the employee part one, and the department part one is here, which will have finance comma one. So now that is how in the distributed environment, this is how the group by, and this is how the you can say the join operations will be working. You always need to bring the data which is having similar kind of values at one single place. Only then you will be able to perform a join for this thing. So that is the only thing I wanted to explain. I know you guys are asking for break. That is fine. So I just wanted to make sure whether it is clear or not. So in the C1, that is how the data was being shuffled from, you can understand, right? Some data of this employee table and the department table was here, and similarly here, and some part of it based on the hash value was moved here, some part will be moved here, and some part will be moved here, and individual joins will be working on, and then we will be getting the distributed output. So yeah, and yeah, let's take a 6 minutes of break, and we will start again, and I will start from this point onwards, right? If you have still any question related to this part. Cool. So what's the time now? We have the 12. Let's meet at 12:10 then. Hello, are you guys back? Okay. Awesome, awesome. Cool. Okay, so guys, what I was thinking while explaining all these things and seeing your doubts. So, what do you want me to continue today? Because after this explanation, our Hive architecture will be done. Okay. So my next part would be basically to talk more about the practical perspective, right? The doing exercises and all. But before that, I can see like a lot of doubts even when I was explaining this part, join how this data was getting shuffled here and there. You guys was pretty much confused on the map reduce part as well, right? So what do you want me to like continue? Because I don't want you to continue even on the practical side without like just having the half understanding of anything, any smaller doubts you have, right? First I want to clarify, uh, because I am also feeling this thing that sometimes you guys are completely lost in some small components, right? Right, so that is the thing, right? I maybe uh, what yeah, I can see recap, go through practical and be covered. Yeah, practical can be started tomorrow as well, because we are about to, at least for this part, the architecture, that is something, right, which is getting closed here, so not an issue. At least Hive architecture part, you guys will be pretty much sorted, and then yes, I can talk. So even before talking about the summary, first, now what I want to do, I want to uh, understand your doubts, right? Probably I can spend next 2-3 hours with you all to take your questions one by one. Even you have smaller doubts, feel free to ask, right? I want to clarify it on the go. Okay. And then after that, so tomorrow onwards, yes, our prime focus will be more on the practical side of the Hive running queries on the environment. And that is why I don't want you to be any don't want you to be like feel confused. Okay, the map reduce is something which you haven't heard before, or completely lost, you are not getting the terminologies or these kind of terms, right? So yeah, that is something. So let me first finish this part, the architecture part, and quickly what I'm feeling that I need to take up your question, and you can ask anything related to the Hadoop or what you have studied previously. So next 2-3 hours we'll be spending directly onto the Q&A part. Whatever is confusing, right? So let's say you guys have already understood it, whosoever knows about it, that's pretty much good. But like I need to focus on every individual who has joined this curriculum, right? Because this course is for everyone, not just for who understood it clearly. For everyone, even if you have a minor doubt, right, it's my responsibility to clarify it out, so that you are like coming out as a best data engineer. That's what I want. So agree. Awesome, cool. Let me first complete it. Okay, so where I was. So that is probably my speed, right? I focus more on the elaborations and all, because practical understanding, I know even if I just guide you a little bit, after that you guys will be able to complete the things, assignments ASAP. But in the live classes, I want to give more and more my practical experience, not just in terms of the technical, but whatever I have faced in the company's interviews, what I've been doing, everything. I want you guys to be professional data engineer after 6-8 months, right? When this course will get ended, and in your first shot, you will be able to crack the companies. That's my main agenda, right? Okay. So quick summary again, architecture part. Now nothing much is left, but three things are which are important to understand, right? And I will talk about it. Those are important to understand. Okay. So here we have talked about the client part, right? We have talked about the driver part. We have talked about the compilation, the parsing, the planner, the execution plans, right? We have talked about the DAG as well, right? What is that? And we have talked about the optimizer as well. Okay, so after that, like once our optimization part is done, the last step will be this one, right? So last step will be last step will be okay, again I will just write a sequence so that you guys are clear. So here let's say our HQL query will come to like after that what will happen, there are different names you can give it to them, parsing or compilation. I'm giving a summary here, then I will move on to the remaining parts of the architecture. Compilation, or you can name it as a planning as well. Okay, now after that of what will happen, parsing is done, compilation, planning, and then we will be having the optimizer. Okay, so after that we will be having the main execution. So SQL part, you guys understood it. You guys knows about the clients, what is being used. So as soon as query will be here, so SQL, it will be captured by the driver program, right? And the responsibility of our driver program is to accept the like incoming SQL request or Hive queries which are coming to the Hive engine, and then after that maintaining a session for it, then passing it to the passing it for the next phase and maintain or even collect the result, right? Whatever is there, and all these responsibilities will be catered by the driver. And yes, the metadata part, good. Now the parsing, compilation and planning was basically our main related to syntax check, right? And the execution plan, correct? I hope execution plan and all these things are also clear. Now talking about the optimizer, it will basically pick minimal execution plan, right? Metadata part of the driver. So metadata part of the driver, Shiva, is basically what happens, as I said, right? Since we are in the Hive engine, what is going to happen here? You will be reading the data from the HDFS locations, right? And also while doing the execution, right, it will have its metadata, the number of let's say the task, the memory required, or the wherever the file is actually located in the HDFS, right? All those things are something related to the metadata of that particular Hive query. Okay, so that is something which will be taken care by the driver here. So the way you treat name node or master in the Hadoop cluster, so similar sort of thing you can consider driver, like doing all those responsibility, maintaining the sessions, reading the incoming request, passing it for the next execution, collecting the data, and just maintaining the data, maintaining the metadata for the execution. So driver maintains those info. Yes. So I will talk about the other part, right? Where I think you guys are pretty much getting confused with the part where like the meta store of this is there, right? Okay. So let me explain that part. That is something which is main part to talk about. Now, once that is done, this execution part will be here, and this execution part is something which will be like executing our map reduce task. So before that, see, before the execution step, the only thing was happening the planning and plotting, nothing more than that. So main execution, like how many number of map tasks will be created and how to execute it and how many number of reduced tasks will be there, right? So all these things are something which will be done in the execution phase. So actual execution, What is CLI client? Yeah, so everything will be explained. Don't worry. We will have the doubt session and I will explain things there. So actual execution is done, right? So this part is pretty much sorted, right? The whole architecture part. Now, the most important part. And here I will talk about few interview questions as well, right? So this architecture part is done. Now just imagine, right? Take an example of any SQL, right? So see, when you install MySQL in your system, what will happen? You are able to create the tables, right? You will be able to alter it and everything, right? And how many of you have seen that all these kind of databases maintain some metadata for themselves? Let's say in MySQL, how many database, when you write or when you fire this command, let's say show tables, show databases, how this information is coming out? Because our MySQL is also maintaining some kind of data about the data which is stored in the engine or the database, right? Number of tables in the DB, etc. Correct. So you understand it, right? So every SQL engine or framework we are having, right? They under the hood or in the backend, they maintain some metadata for sure, right? And same thing, this Hive also does, right? So let's say whatever tables, right, we have created. So in Hive, moving forward in the practical classes, we will be studying about two things, right, which is very much important: the internal tables, right, and the external tables. External tables, right? We will talk about it. So not just internal and external, or even let's say databases, right? So everything, right? This information is what? This information is collectively the metadata. So metadata, eventually the technical definition of metadata is a you can say information or data about any actual data, right? Or any like informational stuff which is related to any file or any data or any application, that is actually known as the metadata, right? So similarly, now if I go back to the architecture diagram, so in the architecture diagram here you can see this part, right? Where it is. Yeah. So this big box was for the complete Hive engine driver. So this Hive engine eventually keeps on interacting with a meta store. So this meta store, the responsibility of meta store is basically to maintain all the metadata which is somehow being useful and being created and being executed in Hive engine itself. And this meta store or metadata is eventually about the tables or the data and the databases we have created in the Hive. Nothing more than that, right? Is it clear? This meta store in the metadata, why it is needed, right? Because if you don't have any information that what kind of tables you have in your system, if you run the show tables command and if you try to even do the select star tables and your Hive engine or the SQL engine is not able to find where those tables are located, how to get that data, you won't be able to execute anything, right? So that metadata information is pretty much required for any kind of database, not just only Hive or SQL. Whatever databases we have, practically they maintain this kind of metadata. So I will tell you the difference as well when we talk about, let's say, the MySQL, right? So in MySQL, what happens? So MySQL is definitely a relational database by itself. So any answers, where does it maintain? Like MySQL, where it maintains its metadata? Yes, schema is also sort of schema definition. Let's say when we basically write that thing, right? What you say, the, let's say, describe table, you get the entire information about the schema, the same data type and everything. So everything is a metadata, right? So whatever information you can get without executing a table, that is somehow you need to treat as a metadata. Okay. Cool. So yeah, whatever answers I'm getting for the right. So in a database in my, yes, exactly. So if has installed MySQL as well, when we will study about the MySQL and SQL queries. So the MySQL by default creates like there will be a default database as well, right? It will be named as sys or user, something like that, or even MySQL something, right? So that is how MySQL will have a default database where it will create few tables, default database, right, where it will store the metadata. And these in this default database, whatever tables will be created, those will be created by the MySQL programs itself. Like when you install things, right, in the backend there will be few programs running which will create all these kind of default databases and default tables for you, where all the metadata entries can be maintained, right? So in the similar way, so when we have the Hive, right, so obviously this is our Hive engine. We, let's say, fired a create command, create table command. We have fired on our Hive, right? So obviously after that, let's say table ABC got created, right? ABC got created. It had, let's say, schema of name, comma, salary, right? Something like that. So this table name, this particular schema, the data type, let's say string, right? Then integer, something like that. So this is this information, anything about the table, its column, its schema, this is the metadata. So Hive definitely wants to store this data somewhere, so that what will happen even in case of any failure or any kind of crash, when your Hive service is again up, you can directly point to those particular tables, you can directly execute those tables. That is why this metadata entry is something which is important. So where this Hive actually maintains the metadata. So for that one, there are two things, right? When you install Hive by default, so it will use Derby database. If anybody don't know about it, take a note of it, because this is one of the interview questions as well. By default, which when you install Hive for the very first time, which database Hive will be using in order to maintain its metadata. So it will be Derby database, which is sort of RDBMS, Relational Database Management System, right? Now, this is the this part is clear, right? What is Derby here? It's a RDBMS and why it is being used. Good. I'm coming on to that, right? What you are asking, can you use Oracle on also or Postgres? Now, I want this answer from your side as well. I have talked about Derby. Now, what do you think? Is there any mechanism that we can use any external database in order to maintain the metadata, right? So I will talk about the drawback of this Derby as well, and why we can use other, and why we should use other external database for the metadata. Cool. So the Derby is something, right, which is the integrated one with the Hive engines, right? When it comes, when we install the Hive packages and all, it will come directly with that. So even by any chance, let's say you have to reinstall your Hive, right? By any chance, obviously all the metadata related things will be gone because it was installed in this Derby one, right? And another drawback is that with Derby database, you cannot create more than one connection at a time with the Hive, right? This is the drawback. So this is the main reason, like this is one of the interview questions somebody can ask, that why Derby database we are not using, right, what you say, with the Hive engines. So this is pretty much sorted for the development perspective. If you want to just maintain one connection and want to test out something, right, that would be completely fine. So not more than one connection. What does mean connection here? Let's say I have written two Python programs. From one Python program, I have already I'm running to Hive again, then it won't be possible. We will start getting the exceptions, right? Hello. Okay. Is my voice fine now? Okay. Is it fine? Okay. No worries. So I was talking about the Derby. So for the Derby one, right? Why we actually don't prefer this default database which comes with the Hive itself, because it won't allow more than one connections at a time. So let's say you have two programs here, right? So this is program P1 and this is program P2, and this is our Hive which is running with Derby database, right? Let's say this was the program which you executed first, so it was successfully able to make a connection to Hive because Derby allowed that one connection. But now, since that connection is already established and getting used, if you try to execute this program P2 to make a connection to Hive, right, that will not work, right? Not connected. Why? Because Derby is not allowing more than one connection, concurrent connection to be executed, right? So that is the disadvantage. And another disadvantage, since it comes as a default database with the Hive engine, so anytime if you are reinstalling your Hive, all your metadata information which is stored in the Derby will be completely gone. Okay. Now I will talk about the external databases. So this is completely true. If we have Hive engine, we can simply configure our Hive in such a way that it is not using Derby database. Instead of, it can use any external database, and it can be again anything, let's say MySQL, Oracle, Postgres, whatever you want to use, right? So now this will work. It is all about the you can say the configuration based thing, where what you need to do, you need to make a connection to this one, right? So that is how this is our external meta store, you can say. Now I will leave this question to you all, that if we are using external databases, what kind of advantages we can get from it. Let me know in the chat box. More connections, go. Yes. Multiple connection first. Yeah. This is the first one, correct. Data backup. Yes. This is also another one, another important. Even we restart, data security, correct. Data won't be large. No single point of failure, correct. Speedy fetching of data. Data persistent. Cool. I think you have completely got the idea, right? What kind of things we were trying to achieve, right? First thing, right? Obviously, it's a external database we are using. External DB. Now, second, metadata backup. So even in case if we restart our Hive, since this is our external database, right? Our data is completely safe there because we haven't restarted this one, right? And obviously more and multiple connections, more multiple concurrent connections. And another thing is something, right? Since this is the external database, it can be exposed for other use cases as well. Let's say you know the metadata and what you want to automate something. Let's say on daily basis, you want to see how many new tables have been got created, how much the data volume has been grown for this particular table. So all these kind of matrices you can generate for this one, right? So this the expose for external use cases, expose to external use cases. So this is the practical example. So in Paytm, right, I actually worked on this kind of use case where since that time I was also learning the Hive part. So I figured out why this Derby part is not, let's say, working. I tried to set up MySQL by my own and tried that connection. Multiple connections were happening. And what after that, what was the task? Basically, I tried to automate, right, to generate, because in Paytm, Hive was the only point where uh, all the business units were firing their queries, and on daily basis lots of new tables were getting created, lots of data were getting ingested. So as a data engineer, I tried to automate this process, because sometimes business users are unnecessarily trying to create the tables and they completely forgot to clean it up, and it will eat up unnecessary space in our cluster, right? So these kind of automations you guys can also apply if you are a working professional, right? This is one good project idea I'm giving it to you, that these kind of smaller optimizations you can do, right? It will help you in the space cleanup and all. Even like unnecessary tables are getting created, you can write an automated script which will point to this external meta store, and from there you can read that metadata and information. And oh, you are a business guy, cool. So don't get offended, right? So what I meant to say that basically this is a common practice, right? People just come and write their ad hoc queries, their ad hoc tables, and they completely forget about it, and then it will come to the main engineering team that why too much space is getting occupied over the cluster. So time to time we need to do that cleanup, and that's how we can automate this process. So can we use non-relational databases? So Prajwal, non-relational databases won't be giving that sort of flexibility, because because non-relational databases are not don't work like a you can say the transactional databases where ACID properties are maintained and these things. But when we talk about this fast fetching metadata information, right, and the frequent updates, writes, and these kind of atomicity and all these things, then we need these kinds of transactional databases which can handle our metadata part, not the NoSQL database. Any use case as of now where any external NoSQL sort of database was getting used as a metadata, because here it is not the actual data. Metadata is also very tiny in terms of the size, right? So that can be handled by the transactional databases like MySQL and Postgres. Cool. So the architecture part, I'm pretty much confident that it is done. So now just let me know one thing, then probably we'll move on to our main Q&A part. I know next couple of hours I'll be spending you to resolve your doubts. But first, just summarize or just help me to understand this thing, that whatever we have discussed in terms of Hive today, its necessity, why it is needed, and fundamental of architecture, all these things are clear to you or not? Clear. Cool. So can I say this, like tomorrow onwards, we can focus more on the practical part, because that is something which will give you more clear visibility, because just going through with the, let's say, theoretical aspect, okay, how this architecture, blah, blah work, that is completely fine. But at the end, practical understanding is very much important, right? So from tomorrow onwards, we will be more working more on the like executing the queries. And before that, just a heads up for everyone, since the Cloudera virtual machine and these things are installed in your system. So what you can do, you can try to execute Hive. Like let's just open the simple terminal there, and not terminal, then you can open the Hive, and from there you can open the Hive, right? If you have opened the terminal, simple type Hive there and hit enter, Hive shell will be open for you. If not, then if you have opened the let's say the Hive, so there will be a drop down option where you can pick multiple options to execute. Let's say if you want to execute Spark, you can pick that one. If you want to execute Hive, you can pick that one. So That's how it will be. So anybody, Sandeep, if this is your first class, right? So what I would say, you would have got all the accesses. Make sure you watch the previous classes. The setup related things was already explained. So that won't take much time. Other folks have already done it. So you can also quickly done it, right? And this is for everyone who is joining it in the middle or the first time, right? You can watch the classes from the day one, whatever things you guys were supposed to be installed, and that was clarified for all the users MacBook, Windows. So you can do it. And one surprise is coming in upcoming days for you all, which will resolve all this kind of your system related hustle. And I won't reveal that surprise as of now, because we were working on that one very hard. And once you will get it, you will be completely amazed, right? So just wait for that one. Cool. Yes, Sudhanshu sir would have told a few small things, but we have integrated so many things, right? So Sudhanshu just might have give you the hint, but I know what we have included, right? So nobody can provide that one, and that is why I'm saying whatever you have installed so far, uh, whatever you have installed so far from the Cloudera, because those understandings are very important. Because as I said, right, in Paytm we were completely on the Cloudera environment, so understanding of those things are pretty much important. But yes, once you will have that lab environment, right, doesn't matter if you have Windows or Linux, Ubuntu. What you need, you just need a simple internet connection and your machine, that's it. And doesn't irrespective of the type or the core or the processor, whatever it is, you don't need to worry about it. Just play on that environment, and you will definitely love it. I mean, I'm pretty much excited because today I was supposed to uh, run all those practical queries on that lab environment, but no worries. We will spend our today's time basically for the doubt sessions, right? So everything will be done. Don't worry. It's not for our batch. It will be for everyone, right? Don't worry. How it is possible that something we are preparing for next batch, not for this one? No, that is not. Cool. So okay, now what I'll do, we will spend next couple of hours on our doubt clearing part. So one by one, you guys can raise your hand. I will be unmuting yourself, and we will start with our questions. And make sure, see, as soon as if you think that your question has already been answered in direct or indirect way for other question, right? So you can hand downs, right? and and again, please make sure your questions are typically related to the technical things, like the questions and all. And time to time we will be having other kind of Q&As as well. But since we have covered the Hive architecture today and things related to that one, now we will be focusing more on the Q&A part. Whatever you have, be it the MapReduce, Hadoop, Yarn, Hive, or blocks, execution, DAG, whatever you have, just ask those questions and I will explain it for everything. So now I am switching to the members, right? And let me first stop sharing. Cool. So all right, just a second. Okay. So first from Devanan. Yeah, you can unmute yourself, Devanan. Hello.
I can hear me.
Yep, I can hear you.
Uh, Actually, as of now, I don't have any question because maybe the hands has been raised by mistakenly by me. But as of now, I don't have any question. Thank you, Sushant, for this session.
Okay, so the Hive architecture and these parts are clear to you, right? And not any technical questions related to MapR and other things.
Yeah, I can say like as of now, I am just understanding when you explain the things after the break. That time I understood the things more clearly. But before that, I got confused due to some new terminology and concept. So now, as of now, I'm good. I can say, yeah.
Okay.
Thank you.
Awesome. Cool. Okay. Now next is from Paresh. Let me unmute. Yeah, just a second. What's happening? Yeah, Paresh, please go ahead.
Yes. Hello. Are you able to hear me?
Yep. I
Hello?
can hear you.
Yeah.
Yep.
So the question is, whenever we execute a Hive query, so before the execution, before 100% execution of the mapper, the reducer starts. So why this happens?
Before 100% of the
mapper execution. So before the mapper is completed 100%, I mean it's 90% or 85%, but the reducer job starts.
So see, in that case, right? So those kind of operations, right? So this is only possible for those kind of scenarios, right? I'll tell you the scenarios as well, right? So let's say the intermediate output got created. Let's say the join operations and simply let's say, again, we'll take an example of that word count problem. Okay. So after the map part, what will happen? The sorting part and the shuffling part will be happening. Correct. So let's say the one reducer, which is now full with its capacity and it has received all the relevant data, right? After the sorting and shuffling, which is supposed to be getting executed on that particular reducer. So why would even it wait for, let's say, the entire 100% map task to get completed? It can definitely starts its execution part on that, or let's say that runtime itself, because it has received that sufficient amount of data, right? Base or whatever keys were supposed to go on that particular reducers, it has received it. So it can definitely start its processing part. So whenever there will be these kind of there will be like these kind of use cases. I think you can unmute yourself again, Paresh, if you got unmuted. Okay, but still I'll complete this part. So whenever we will be having these kind of use cases, right, where things can be started or the sufficient amount of data has been received at the reducer side, right, it can definitely start its execution. It will not wait for anything to get completed, because that's how it will save the time as well, right? So that's the simple reason for it. Next question from the Balvinder. Yes, Balvinder, please go ahead. You can unmute yourself.
Hi, Shashank. Good afternoon. I mean, it was really nice session, Shashank. Actually, I have got everything, whatever you explained. Thanks a lot for that. I think my hand got raised by mistake. So to be very honest, I don't have any question. But thank you for for the amazing session. Thanks.
Cool. Great. Thanks. All right. So we have next question from Rajbir.
Hi, Shashank.
Yes, Rajbir, go ahead.
Yeah. So first of all, I mean, really impressive explanation. I mean, I've seen a lot of video on YouTube also, but this kind of explanation I've never get. So really deep. I understood everything. My question first is regarding the when everything executed, I mean map and reducer, now it's come to the result part. So how result come back to the client? I mean on a different container. uh, I mean how it comes from the different container and club together and give it to the client.
Okay.
You can explain this.
Okay. So see, this will happen in two ways, right? It will depend that the way you are trying to write your data. Okay. So here in the typical map reduce, what we talked about, let me share my screen again, and I will tell you that what I'm trying to explain, right? So in the screen, right, we talked about multiple, let's say map task, right? So there can be multiple map tasks which will be created, right, based on the number of blocks you have, right?
Correct.
So this is, let's say, task 1, the task 2, and the task 3, and the task 4. And let's say in our cluster, we had this one container C1 where two reducers are running, R1 and R2, correct? And we have another container where two more, or let's say simple one container is running, which is, sorry, one reducer is running, which is R3. So these tasks will be generating that intermediate data, right? Intermediate key value pair. And after that, what will happen? The sorting and shuffling will be happening. Sort and shuffle will be happening. Okay. So once the sort and shuffle phase, it will decide that which record will go onto which reducer, right? So this kind of cross exchange will be happening from this point onwards.
Right.
Okay. So now these reducers, this individual reducer process is something which will be processing some amount of the data, like let's say doing the summation, finding the maximum, minimum, and these kind of aggregations. Now it's up to you if you want to write the single file as a output in, let's say this is your output directory / output, correct?
Correct.
So if you want to write a single file into it, let's say result.csv. So if you want to write it, so in the way you would have written your program, right? So in the reducer functions, you would have written, let's say, if I can talk in terms of the Hive, so there we have either the order by or the sort by, right? And even to basically write the whole data in one particular file. And when we will move on to the Spark, right, there are specific operations to read the data and write the data, where you can use that how many partitions you want in your output directory. So by default, if you are not trying to write the data in one single file, so the number of reducers jobs are running. Each individual reducer will try to write its own output. So let's say the data which is being prepared by R1, right? You can call, so how it will be written in the output directory? Output, it will be written as part1.csv. That is why in the beginning I mentioned multi-part output you will be getting, and you will see part2.csv and part3.csv, right? So that is how the number of reducers you will be having, those number of output parts you will be seeing in your final resultant directory. And when we talk in terms of the specific, let's say Spark, so there again the distributed computation will be happening, and there is a concept of increasing the number of partition and decreasing the number of partition. So at the end, right, doing the operation, we can use the let's say repartition and coalesce function in order to increase and decrease the number of partition, and those number of resultant partitions will be written in the output directory, correct? So that is how this whole writing part is being done. Even if you are supposed to write whole data in one CSV file, that is also configurable. We can mention that property, and it won't be a multi-part. Everything will be written in one single file. But since we always talk about the distributed environment, so I think this is the best part where we can, if we can produce our output in a multi-part way, so that if there is another job which is consuming this data, this is already distributed, and there will be no need to repartition data on the runtime itself.
Okay. So I think this, I mean, this happened when we connect Spark or Python with the Hive. We can write data after analysis or something, after analysis or pre-processing. When it comes to the Hive only, when we write select query to get the output on the console itself, then it comes, you know, together. It is not in partition and everything. So there, I mean, it's an internal function that return the one output.
Yeah, so
or
it is internal, and that is something also even on the Hive side. There are configuration properties, right, which we will talk in practical, which you can set to, let's say, define few number of reducer itself and the mapping itself, right? So that is doable. Like multi-part output will be also written, and the single part as well, and everything is doable with Hive.
Okay, okay. My second question is that since this Hive has the optimization tool also internally, when we write the query, it I mean checks the which one is the optimized one and send to the execution plan. So we often, you know, listen that, you know, how we can write optimized query. So is it different from that, or whatever we write as a query, a simple query, optimizer check itself and takes only optimized thing only? I mean,
So yeah, so multiple level of optimization it will do, right? So first we talked about the execution plan. So see, from our side, we will, as a let's say analyst or in data engineer, we will always try to write the most optimized query. So optimized query as in, so far we haven't talked about the advanced concept of the Hive partitioning, bucketing, using partitioning key in the where clauses and all, right? So those are the
correct.
best practices in Hive, right? And partition our data, which sort of size and all these things, right? This thing will come into the picture. But when we simply talk about the execution plan, after once the execution plan is being created, optimization will obviously will pick the minimum, the execution plan which is giving the minimum cost. And apart from that, in terms of the transformations as well, right, I gave you that example, and this will be much more clear to you when we will discuss this thing in Spark, because they're much more broader and important transformations, right? But here itself you can understand, wherever there is a need, right, the sequence of transformation can be shuffled in order to reduce the data size. Those kind of optimizations will be also taken care by the Hive optimizer. Let's say as an engineer, I have written down a SQL query and I didn't realize, or I don't know that which where clause should be placed where. Based on the logic, I am just trying to solve a business query. Okay, I have written the entire logic, but the way it should be optimized, that will be known by Hive itself, because it knows the data, which filter operation it can place before which group by operation or which join operation. So that kind of optimization will also be provided by Hive.
Okay. Now last question. Uh, uh, Hive uses the HDFS as a storage layer, right? So apart from HDFS, is it compatible for other storage layer also, like S3 or something else?
Yeah, definitely. So not just only HDFS, it can definitely read data from S3 as well, or any kind of persistent and distributed storage system you will be having, right? From there we can consume the data in Hive.
Okay. Thank you very much.
Yeah, cool. So next in the sequence we have Henry. Please go ahead.
Thanks, Rishan. I want to thank you for the class. You really did justice to it, and you can see there's no question. Thanks so much.
Okay, great. Thanks to hear that.
Yeah, I have one. It's a take-home task, an interview question. So I wanted to share it. You probably give me a guide on how to approach it. I've been facing some Yeah, so I don't know if I could share my screen, probably maybe give me an answer so that I can see it and probably give me.
Just a second. Let me. Let me try it out. That how it can be more talking chat. Yeah. Now try that because you're part of panelist now. Hope you can try it now. Henry? You can unmute. And you are part of panelists as well. Now probably you can.
Okay.
Are you able to share your screen?
No, you need to allow me share.
Because change role to rename, allow record. I don't see any option. I can see that hosts option. I have already made you part of panelists, so I thought you should be able to share your screen, change role.
They said host should disable participant screen sharing.
But if I make you host that, then I will lose it right as a host. Yeah. Not share screen share. I think adding into the panelist should have worked, but allow record local files, change role to attending, make host, pin. Probably you can explain the problem statement. Like I'll try to help you out if you can quickly explain.
Okay,
I'll figure it
because
out.
I
To
wanted,
share the screen. Yeah, for the tomorrow's class.
because why I wanted to share the screen is that they give a diagram and some other stuff, but I can.
So you can
I can
talk
read
about the diagram components. Then it would be helpful.
Okay, the diagram components, they have like an input file with a driver, with workers. Then they are saying that they created a spread map reduce program to solve the word count problem on your local machine. The server client communication should use either GPRC or REST API, whatever you prefer. The problem is input is set for text files, and you want to produce count indicating how many times each word count is in the data set. You can use any programming language. So,
Hello.
yeah, can you hear me?
Yeah, I can hear you now. I lost you for a while.
So they're saying that the server client communication should use either a gRPC or a
gRPC
REST
calls
API.
or REST APIs.
Yeah, whatever you prefer. The problem input is a set of text file, and you want to put a count indicating how many times each word occur in the whole data set. You can use any programming language of your choice, but please only use standard built-in library. And if you choose that on a high level, you can code should function as follows. So the function as follows is the diagram. So they gave a hint, they gave some stuff, they gave a driver, and the rest. So
Okay,
that's
so
why I
he's
wanted
asking you to write a simple map reduce program to perform that word count problem, and the extra addition here that where you need to call the gRPC, where you need to make a gRPC call.
Yes.
Like I'm asking this question where you are supposed to. So probably Henry, what you can do, you can mail me. Probably you can upload that diagram in the mail, in your drive or something, right? And you can mail it to me, okay? And I will have a look into it. Probably then I will be able to provide more inputs, because I'm also not getting that option where you can share your screen. Probably, yeah, again, this is the first class. Maybe I might be missing something. So I'll rectify it tomorrow. But yeah, if you can upload it in the drive itself and you can mail that link to me, I will have a look into it.
Okay, can you give me your mail so that I can your email address?
Sure. Just a second. What was the? I'll ping in the chat, right? Just let me pull it out, my official email ID, right? So just again. Meanwhile, we can move ahead with the next question. So I'll give my email ID as well. Meanwhile, I'm trying to find it in the chat, but yeah, I will move on to next. So next question from Ekta.
So, hi Shashank, thank you so much. Finally, I'm able to speak to you. So, first of all, I'll be taking you a couple of minutes just to thank you, because thank you will be a very, very small word, because I am somebody who passed out BTech in 2014, then MTech in 2000, sorry, BTech in 2012, then MTech in 2014. Then I was having my own life struggles with marriage, with my daughter and something. And probably you are somebody who introduced me that data engineering is a kind of field that is prevailing in India also, because earlier I used to think that, you know, data scientists are the people who are taking care of engineering tasks, analysis and everything.
Mhm.
So the kind of motivation you have given me, you can understand it yourself. Because I am somebody who is giving a new start to my career in my life, and gratitude to you, blessings from my side. I'll pray to Almighty to give you lots and lots of success and happiness in
Thank you
your
so
life.
much. That means a lot.
Yeah.
And
Now, just a small question.
Mhm.
Yeah. So, Shashank, I just want to clear whether I am understanding all the three components in layman terms very clearly or not. So, first of all, we have discussed these three components, like in Hadoop, HDFS is there, that is responsible for handling distributed storage, right?
Mhm.
Then we are having MapReduce, that is something which is responsible for taking care of distributed processing.
Correct.
Then MapReduce was something that required us to do a lot of coding in Java. And as data professionals, it was getting difficult to do all that. That's why Hive came into picture. Am I right
Correct.
or not?
Yes, yes, exactly.
So Hive is something that is compiling our SQL to that Java kind of code at the backend for us,
Yeah.
right?
Yeah.
Okay, so I just wanted to make sure, because, you know, now I'm having an insecurity whether this is the same old Ekta or I need to brush up my brain or something.
Yeah, this is your understanding is correct. So that is why I'm telling, right? So this whole part, so nowadays in the industry, right? Nobody is, again, I said why there was a necessity of Hive, because nobody want to invest that much amount of time, right, in order to complex coding part. Because in the big data domain, right, we have lots of job profiles. Let's take an example of data analyst, business analyst, right, and even data scientist. They don't want to deep dive too much into the complexities of writing that typical MapReduce code. Okay. And
Yeah.
that's how the Hive is simplifying and making their life very, very easy and very, very adaptable, right? So whenever you will pick the job description, or whenever you will apply in the job descriptions or different companies, right, you will see Hive as a required skill set, because this is the most widely used data warehousing service for most of the analytical queries. I just named few companies like Paytm. I practically worked on it. MX is there. Tokopedia was there. And then the Grofers or Blinkit, you can say there. And many more companies who are into the data analytics. You will definitely see that they are using Hive for their analytical queries if they are not onto the cloud.
Okay, great. Thank you so much for clearing out. Thank you.
Yeah, cool. All right. So moving on to next question from Venkat. Hey, Venkat. Yep.
Hi, sir.
Hey.
Yeah. The thing is, basically JDBC ODBC connection is required if we are going to connect to Hive through programmatically. That's
Yes.
what I got. This is
Yes.
right, no, sir?
Correct. Correct.
Okay. So there we will be seeing the thrift, right?
Yeah. Right.
Yeah.
Because
And one more.
that will move from like JDBC. You will be having all that connector package, which will help you to connect with the Hive, right? So Hive is also something which is installed somewhere. So it has a something backend daemon process, which is listening to the request, right? So the thrift is that kind of daemon service.
Okay. If we are going to connect through any CLI or web interface, no need of JDBC ODBC connection.
No, not at all. Not at all. Connectors will always be needed whenever you want to connect to any kind of, again, not just only Hive. Again, if you want to connect to MySQL, right, programmatically, you need JDBC connectors or ODBC connectors.
Okay, so by considering that driver, I consider driver as a master for the, like a master. So
Mhm.
even driver stores the metadata, right? So again, we have meta store. So what's the difference
Oh,
between
so
the?
yeah, so the driver is not maintaining the metadata about the data which is getting stored in the Hive. So when I explained the meta store, right? So what kind of information it was holding? Let's say how many databases, their databases, right, are there, right? And after that, what was there? Like the schema. Simply when you will run a, let's say, show create table or describe any table name, you will get, okay, how many columns are there in particular table, what is their data type or the primary key, and these kind of things. So how this is getting stored? As soon as we created a table, one entry will be maintained into the backend meta house, right? And that is how this is the metadata which is getting stored in the meta store. But the driver, it is not storing anything, right? It is not storing anything. As soon as, let's say, it received a Hive query execution, what it will do, it will parse it and it will create one session for it. So within that session, for that particular query, whatever is required to be executed in terms of the metadata, file is where file is stored, right? And let's say any other metadata, right, which it needs for the execution perspective, that is something which will maintained by the driver within that particular session. And once that execution is done, it will be vanished. So driver is not acting like again another you can say metadata or warehouse which is maintaining additional metadata. For the simple metadata of the tables, databases, their schemas, and any other sort of value, it is there in the meta store which we have created separately.
Okay, so now, okay, if you don't mind, like what is analytical data? Like people used to call that.
Okay, so analytical data is anything, right? See, analytical data, if you want to understand in the technical terms or the business perspective, so whatever data which you want to analyze or whatever data which can give you the meaningful insight to you, you will always consider it as an analytical data. Is it?
Oh yeah.
So, and that can be anything. In the initial classes, we have talked about this thing, right? That the structured, unstructured, and semi-structured. But whatever data is there, which can give you the meaningful insights, will be simply known as the analytical data.
Okay. So basically, if a job or task is created, it will be performed in one container, right? So each container is having each task, right?
So there will not be only one container. So as soon as when you submit the job, right, for the execution, so it will analyze that how much amount of data it is going to process. And based on that, our resource manager, which is Yarn, it will try to acquire those many resources from the cluster itself, right? And resources means basically allocating that number of containers. So we can always be more than one as well, based on the amount of data which we are going to process. And within one container, there will be multiple tasks running on based on the virtual cores which we have for one container.
Okay. Okay. So basically, we saw bad, good, and high. These are the three words. So based on the based on number of words, there will be number of reducers, right? In the
no, not based off number of words. So reducer is something, right, which you shouldn't think that let's say we have 100 number of map tasks, then there will be 100 number of reducers as well. So it's not like that. Reducers will always be less in terms of that, because they are just doing the aggregations, right? And mapper is something. So let's say somebody asks you that we have this particular job, can you calculate that how many number of mapper tasks will be created? So let's say you stored 1 terabyte of data and 100 blocks got created for it. So one block means one physical data part of your particular file, and one map job will be working on one particular block, and that is what we will know as the task as well, or we can call it as a mapper task as well. So let's say 100 blocks were created and 100 input splits were there. So we will call it as 100 map task got created. So individual map task will work on their task, like key value pair it will generate. But the work of reducer is always to reduce the data and aggregate it. So that's how they can be minimum in numbers, and they will try to collect all those kind of key value pairs which are having same sort of values after the sorting and shuffling phase. And that is how they will be able to sum it up. So that is the reason, right? Don't get confused that for individual word there will be one reducer. So the reducer will be mostly working with the values of keys. Let's say
so can I say it like based on number of keys we can
yes. So not exactly. So again, you don't consider that, let's say 100 distinct keys got generated. So all those keys will go to different reducers. So let's say you had only 10 reducers and you had 100 distinct keys. So distinct keys. So in the even to distribute the data in even fashion. So what can happen? 10 distinct keys data can go to one reducer. So that's how it will be done.
Okay, sir, and the last one is like regarding the Derby database. I didn't got that. And one more thing, why we are connecting the Hive to the external database, sir?
So maintaining that metadata, right? So again, the simple reason, right? Let's say in your laptop, right? You can store anything. Let's say you have your pictures, right? You have stored in your laptop. And if you're not taking the backup of your pictures in the external hard disk, and if your laptop get crashed, right? So will you be able to get that pictures again?
No.
No, right? So this is a simple reason. So metadata, since we have created lots of data in the Hive, we created lots of tables, databases. So we should be able to maintain that kind of information, something outside or somewhere in the external system. So even though if something happens to our Hive engine, or if it crashes, we can again spin up a new Hive engine and we can point it to that external metadata warehouse, which we were using, or wherever we were maintaining our metadata. So that is the main reason to have, we will always try to have the external databases as our meta store.
Okay, so basically we are connecting Hive to our external database for the meta storage, right?
Meta store, correct.
Okay, sir. Thank you so much, sir.
All right.
Thank you, sir.
Cool. No worries. Next question we have from Yog. Please go ahead.
Hello, Shashank. So, like, just first dot would be in connection to the one which Venkat asked. So basically, Hive is a processing engine. It is not for storing, and HDFS is for storing. So, like, the data that we are creating in Hives, like the tables and all, those data is never stored in the Hadoop part, or like, how does it work?
So yeah, it will be. So eventually when we work with Hive as well, right? So so for Hive, right, again, we can definitely point out that where we want to store our data, right? I'll tell you how this will actually work. Again, let me quickly share my screen. So I'll come back to this one. So I was supposed to clarify all these things tomorrow because it will be more clear to you when we will be talking about internal and external tables, and also like when we create some tables, right, then you will get more idea, but I will quickly explain here. So let's say this is the Hive part we had, right? And here we created one table ABC. Okay. So Hive is something, if you remember the architecture in the downward side, right? I created one layer which was HDFS. Correct. Yes. So as a source, it can read data from different places, and it can write data also different places. But so since Hive is something which works on top of HDFS, right? So here, whenever, let's say, you are creating any table ABC, right? So obviously you will dump some data into this table.
Yes.
Now your question is that where this whatever table we have created, where this data has been dumped, so how or where this table ABC getting stored physically, is it?
Yes. Yes,
right.
Yes.
So yeah, so here what will happen when we configure when we configure our Hive manually. So there are few configurable parameters where what we need to do, we need to assign one path for the data store, or you can say warehouse store of Hive.
Okay.
Right? So let's say in your HDFS, you have created one folder, let's say users and Hive. Okay. And now you are using this directory, HDFS directory, as your warehouse store in that configuration. So whenever now you will create any table and you will dump some data into it, that will directly go into this one. Like there will be some table name, let's say folder name with the table name will be created, and data as a multi-part will be stored here.
Okay. So
Got the point?
like, yes, definitely. Thanks for this. So if this thing is happening, then there is no need for like connecting to the external thing, right? Because already our data is in HDFS and we have like copies and everything. So
Correct.
that is an additional option that it's not always required.
Yeah, it's
to connect
definitely
to.
not required. So see, this part which I talked about, this is for the warehouse of Hive. This is not the metadata. Correct. So that's what I want. Don't get confused. So whatever I'm talking about, let's say the MySQL, which is subsequently working with Hive, this is for the metadata, not the actual data of the table. So what is, let's say, table name, right? Schema, and the let's say DB name. All this kind of metadata will be stored in this kind of external databases. But whatever table you have created in Hive and whatever actual data we have dumped in this particular table, that will be reflected in the warehouse directory.
Okay. So like in layman language, if I have a table with like say column name, employee and salary. So that column name, that name, employee, salary, just that metadata will be stored in MySQL, and the row values like yes, the XYZ salary, and that actual data is in the warehouse.
Yes, exactly. You got it correct.
Okay. And also like just two more doubts. When you were explaining about the map reduce part, you explained about that word count thing. So what I understood is like mapper is basically key value pair. So suppose like the first line was just a second. Wait. So in the first line, you took like 3 words and you gave one value for it because the frequency of that word was like high, okay, bad, good, okay. So it was 111. And then mapper 2, mapper 3. Mapper 1 had the first line, mapper 2 had the second line, mapper 3 had the third line. So when reducer part came, so it is combining, right? So I got little confused there because you explained in the diagram about RD1, RD2, RD3 and gave the IDs. And then I did not get like how the calculation happened. So can you just in shortly like explain that, like how it happened?
Cool. So you got that idea, right? There will be 2 phases. First will be the mapper phase, second will be the reducer phase. Between that, what will be happening? Sort and shuffle, correct?
Yes.
So for mapper function, right, the input will be the one line, right? So let's say you had one physical block. I will talk about this one. So block which is stored in HDFS and it has, let's say, 10 lines of data, correct?
Okay.
So now one mapper, again, in the beginning, I explained this part. In distributed computation, we send our function or our code to the data. Data will not be coming to the code itself. So that means this mapper function will be sent to this one, right? And now in mapper function, what we will be doing, I'll just give you a very, very pseudo code sort of idea to our mapper function, right? It will run a for loop kind of thing, right? Where let's say you had this input text data where 10 lines, right? So it will start from the head of the, it will start from the starting position wherever, let's say, our head pointer of this system is pointing, right? It will start from the 0th line till last line, right? It will start from there, right? So first line was read here. That is why input will be one line, correct? So now if I consider one line, which was, let's say, hi, hello, and bad. This is, let's say, part of one simple line, correct? So
Okay.
now in the mapper function, I have, let's say, first, since it's a word count problem, the simple approach will be to split this line based on the comma character and get the individual word. And in front of that, assign value 1, because since in this, I haven't aggregated anything. Whenever I am seeing any particular word, what I am assuming that I have seen it for the very first time. That is why
Very first
I am assigning just value 1 to it, right? Similarly, bad, right? So processing for, so this will be this line will be the input for, you can see, the map function, and the kind of output it has generated, it is in the key value format. This part is clear?
Yes, yes.
Right? Now, similarly, let's say, assume the another line was, this is line 1. Another line was processed by the mapper function where it was written, let's say, okay. Okay. Another was again hello, and the bad. Right? Now, similarly, on this line as well, the splitting will be happening. Correct? Splitting happened.
Yes, yes.
And now what will be generated? Okay, 1.
1.
Hello, 1. And bad, 1. Correct? So that has happened.
This was my query actually. So this is happening in one mapper itself, or two different mappers?
Yeah,
are
so
taking two
that is
different
why.
lines?
So here what I am referring, this block B1. So let me maybe clarify it more. Block B1 is our one small chunk of the data,
One
right?
chunk.
Which you have read in the initial classes, and it is
Yes.
holding these two lines data. This is the first line and this is the second line. Got it?
Okay.
Now,
So isn't bad won't be value 2, because obviously
that is why I
this-
am saying, so here aggregation is not happening. So the kind of work this mapper is doing, it is simply accepting one input line, right? And it is just doing a mapping, because whatever line it is reading in the map phase, we are not doing any aggregation. That is why for every single word, doesn't matter how many times it is even present in one single file, we will assign one value to it. Got it?
Got it.
Yeah. So now these are the intermediate outputs which has been written into the, so after the mapping phase, right? So this key value output which has been generated, right? It will be written in the disk. Right?
Yes.
So key value will be written here. Now, from this point onwards, what will happen? Shuffle will be happening. Sort and shuffle, you can say.
Correct.
So the task of sort and shuffle is to bring all the values for one particular key at one single place. Means so far we haven't sent anything to the reducer, but what this sort and shuffle is actually doing. So we can see bad is present here, bad is present here. So how it can be done? Bad, and in a list I can write 2 times once. Fine.
Correct.
Right? Similarly for hello, I can write 2 times once. And similarly for okay, I can write only 1 time 1. Got it?
Yes.
So this short and shuffle part is completely focused. Now the reduce part. So for an example, we have 2 reducers running on. Now shuffling sorting has been done. Now the only aggregation part is remaining, like adding this one with this one with this one, like individual aggregation is remaining. Who will do it? Reducer will do it. And how this reducer R1 will know that how many keys I need to process. So for that, in the middle, there will be one kind of daemon process which will be running, and that will be known as partitioner. Correct? What this partitioner does, let's say for this R1, right? It has some let's say defined range. Let's say I will be accepting all the hash values which are getting generated from value 0 to 10, and that's here, let's say 10 to 20. Correct? Now this partitioner will pick this value, like this value, this key value, right? And it will be passed in a hash function. Let's say it generated value 5, hash value is 5. So now this entire intermediate output, where I should send it, I should send it onto this reducer. Correct?
Okay.
Now let's say there is hello again. Hello is another key. We passed into the hash function and it generated value 9. So value 9 is the range for this reducer. So this value, where it should go? It should be go onto this reducer. Correct? Now talking about this OK. If I pass it to the hash function, OK, and let's say it generated 15. So where it will go? It will go onto this reducer. Now this reducer is individually doing the aggregation part. So this reducer, what it will do, it will just sum all the ones which are maintained in this particular list for individual key. So reducer 1, what kind of output it will generate? It will generate bad 2. It will generate hello 2. This output will be generated by R1, and what R2 will generate? OK 1. And this will be the individual output which will be written. You can call it as a part2.csv, which will be written in your output directory, and this will be part1.csv.
CSV.
Now,
okay.
Understood?
Yes, yes. Thank you for this. So, so adding to this, so when suppose I'm a client and I need to see my output, so I will obviously look something that is like as a whole and not like in parts, some part here like that. So for me, I will be getting part 1, part 2 like this, or it will be like combined.
No, so in that case, let's say you can limit. So wherever you have a need that you don't want to write your data in multi parts, right? What you can do, you can configure the things in such a way that one reducer is defined in your job. So all these sort of keys and every sort of data for the aggregations and all will go to one reducer. It will be slow performing, but you will be getting the one dedicated file for it.
Okay. So that is also like we can do it. And like this hash value you gave, right? 5 and that are just random values, right?
Yeah, so that is internally taken care by the framework itself, right? Probably we cannot create our own hash values. Maybe it could have been created in the typical MapReduce program when we work like defining. I think I remember there was a logic of custom partitioner and all these things. So I think I remember it can be done, but by default it is already been taken care by the framework itself.
So we don't have to worry about that, right?
No, we don't need to worry about it. Yes.
The reducer will do its aggregation and give us the output.
Yes. It will be taken care of.
And Sachin, my last doubt was related to DAG part. So actually, if just in like brief intro, if you can tell about that as well, like if you don't mind.
So, okay, DAG part. So what I would say, don't get confused because the DAG is something which will get more clear in the Spark class. But see, understanding DAG is more like, let's say you have multiple operations, right? So I can, the way I can write it, let's say this is your employee input data, right? Employee data. So first what you did a read operation, correct? After that, what you wanted to do, you wanted to do a filter. Let's say filter for the India employees, right? After that, let's say this is your primary data set or data frame which got created, D1. And after this filtration, and for this filtration we did on D1 itself. Now D2 got created. Okay. Now what we want to do, let's say we want to derive one column in this one, right? D3, and that derivation is, let's say, I'm just writing ad hoc names. So derive, let's say salary into 2, right? And this salary into 2 we are picking from the D2 itself, right? D2. Now D3 got generated, and after that, let's say from this D3 I want to generate basically I want to work on 2 operations, right? Let's say I use this D3 to join it with another, let's say in the middle we would have generated another data frame, let's say D5. So we did a join operation, right, on D3 comma D5. Along with that, I had another, let's say D6 data frame, and how it got created. I just did a group by on D3. Correct. So simply, right, we can say that we are having multiple kind of, let's say, transformations we are using, or we are doing some operations here. So what I actually mean from the DAG, so every single transformation, what you can, so here read is not a transformation, just giving you the idea. So how this entire DAG will be created based on the input and output which is getting used, right? So we can see D1 will be passed in this in this one function, and the new output D2 got created. So if we try to just connect them together, so from D1 we had a operation D2, right? We call it as a D2 operation, and from D2 sequentially we went for D3, right?
D3.
And from D3 what we are generating directly, we are generating D6, and using D3 and D5, right? Let's say from here we are moving on to D4. Assume let's say we generated D5 from D2. I can write D5, let's say from D2 we again derive one more column into it, right? So now you can see this DAG, right? So it is pretty much directional, right? From which operation to which operation we are going on. So this DAG is something which is the actual backbone of this kind of you can say fault tolerant execution engines. Best example is Spark. So here every step knows that what was the previous step. So any point of time if this get fails, so it will have a complete information that how I can regenerate myself. So this operation knows that I am coming from D1, so I will just go to this operation and will recalculate myself. So this is the thing which I have drawn here is known as the DAG, or the abbreviation is directed acyclic graph. Here you can say no cycle has been created, means cycle would have been created if I would have connected this row with this one. So this is a loop has been created, but any graph will be directed acyclic if it has arrows, also no cycle. So understood?
That's what you were talking about, linear operations, right? Because you mentioned one example where you have to join 2 tables, so that with common some ID or something. So in that it was like joining. So
yeah,
this is linear, right? DAG, like.
Yeah, lineage graph you can like similarly. So here even if I use the join operations and all, so that will also have the same impact, because ultimately this D3 and this D5 would have been derived from some previous operations. So even this join operation, which is ultimately giving me D4, right, will be a part of this DAG itself, because at D4 the joining is happening. And how this joining is actually happening, I need to add this arrow as well. So for this D4, arrow is coming from this direction and arrow is coming from this direction.
D5.
Right?
Okay. Thank you. Thank you so much. Thank
Cool.
you so much.
All right, moving on to next
Sir,
question.
sir, last question. Sir, I don't know SQL that much, sir. Will it help me in learning Hive?
Don't worry. So we are starting with Hive and we will have a dedicated class for our SQL as well. And I will be taking that class. So don't worry.
Okay, sir. Thank you. Thank you so much.
Cool. So next question, Samreen. Yes, Samreen, please go ahead.
Hello. Hello.
Yep.
Hi, Shashank.
Hey.
Yeah, thank you for the session for today. So actually, I had 2-3 questions. Maybe there will be relevant for other people also,
Okay.
because they are different. So first question is that I wanted to confirm from you that Cloudera is a portal which provides Hadoop ecosystem to us,
Yeah.
and the cloud portion like AWS Azure, where does that fit into Cloudera?
That will actually not fit, or that will not even come under the Cloudera sections, correct? So Cloudera, see, so if let's say I ask you that you have your local laptop, right? And you need to work on Hadoop, Hive, and all those things. So this is doable. You can set up Hadoop in standalone mode in your system, then Hive separately, then Hue separately, and other services, whatever you want to use, correct? That is doable. But that is the part where these organizations come into the picture, Hortonworks and the Cloudera. So what they said, let's make users life pretty easy. Try to package all those things, right, which comes under this space of big data, and to practice everything in one simple virtual box machine, right, and provide it to the user so that they can spin it up in their machines, and they can play around it. Everything will be pre-installed there for them. They don't need to hustle for anything to get installed. Now, talking about the cloud, specifically AWS, GCP, or the Azure, they are the whole separate environment, right? They are whole infrastructure. They are someone who have created these services in order to write your pipelines. They have database service. So whatever you have been getting so far as an open source tech or tools, let's say the MySQL or any NoSQL database, or let's say the Spark, or let's say the Hadoop and all these things, right? So they have created a replicated service for the same, which is running specific to that environment. Like AWS has their own services. So if I take an example of MySQL, we know this is the open source, correct? And for the MySQL kind of like similar identical service, AWS has created AWS RDS, Relational Database Service. So whatever MySQL will be doing in your system as an open source tool, same thing you can use in the AWS as a AWS RDS service. So similar to that, other services as well. So that's how these two things differentiate with each other.
Okay. So, am I right in saying that if Cloudera provides a Hadoop ecosystem, then any cloud provider can also provide the same ecosystem?
Yeah, they can also package like whole solution and give it to the user. As of now, I don't think any cloud provider has created this sort of package, but you can, if you want to learn these things, you can probably create those free accounts and play around those big data services which these providers are giving to the user.
Okay. Actually, I have worked in a big data project previously, and they were using Cloudera distribution only. But the management, we used to hear that the nodes are on premises. So, what does that mean?
Yeah, so that on premises means they haven't purchased any servers on the cloud. They have they have got physical machines in their organization itself, and via routers and networks they have connected those machines, and everything is in their org itself, right? The physical machines I'm talking about that one, not a cloud solution. So that's what on premises means.
Okay, that means that their data nodes will be in a physical location rather than being on the cloud.
Correct.
Okay. Okay, the second question is that you explained a simple example to make us understand about map reduce. So can every situation means other situations can also be handled by map reduce, because word count problem is a simple problem. Can
Yeah,
we
so yeah,
can you give
yeah,
an example?
definitely that can be done. So let's not take an example of simple map reduce. Let's take an example that you want to read two data sets and want to join them together, correct? So that is also doable. For that, if you go ahead with writing typical map reduce code, you need to write your map code in such a way that it is reading the blocks, right, for both of the data sets together in such a way that common keys are getting joined together. So that part will be taken care by the mapping and all. And after that, whatever, let's say, aggregation and other things you are doing can be taken care by the reducer. So that is doable. But yes, extensive map coding and reduce coding is, or you can say basically it is required from your side if we typically go ahead with the Hadoop map reduce part. But when we talk about the Hive, right? So here everything is resolved for you. Whatever query you have written, obviously you would have mentioned one particular table A, table B, and then joining together. So table A is something which is coming from the HDFS, table B is something which is coming from HDFS, we loaded data and everything. So ultimately that Hive is converting your particular query into that sophisticated map reduce code.
Okay.
So that is how it is being done.
Okay. So just last thing about the actually doubt clearing session that we have in our dashboard. So yesterday's the last class I missed, but I watched the recording. Some people were mentioning about problems in doubt clearing session. So I also tried to join that session, and I was actually taken aback. I was very shocked. There was a person named Vikash, and there was a student already asking a doubt, a very simple, trivial doubt about Python objects. That if the strings are same value, then the both the references will obviously point to the same object. So that person was beating around the bush so much. I think he didn't know, or he wasn't experienced enough. So he was telling repeatedly to वो ऐसे कह रहा था कि आप पहले पढ़ो इसके बारे में, आप पहले इसके बारे में जानो, आप गूगल पे भी देख सकते हो, ऐसा कुछ, हाँ, these type of statements. So I was very shocked to listen to this. So is this right, or is this fair to
No, definitely this is something which shouldn't be entertained. So I have taken note of it, right? I'll have a chat with Sudhanshu and we'll directly talk to him regarding this.
I also asked a doubt from him, but I don't know when it will be answered and how it will be answered, because I haven't received a reply. So
No,
yesterday, Sudhanshu sir was giving his phone numbers to privately to some students. So is it fair to all of us who have joined the same course and
no, I'll talk to, I'll have a chat about it. Don't worry. Yeah.
Okay, thank you.
Cool. No worries. Let's move on to next one. Yeah, Mansi.
Hi, Shisham.
Hey.
I have a doubt regarding the FS image and the edit log. Right. So the doubt is like in the secondary name node, it's the job of the secondary name node to merge the FS image file and the edit log, and then it sends this new FS image file to the name node. So what does the name node do? Does it just keep it with itself, or it goes in that safe mode and like reboots itself?
No, so yeah, so sending the edit logs or having the FS image, right, to the secondary node, you already know that is for the backup purpose, right? So by any point of time, if name node goes down, so what will happen means in that case, like every time the secondary name node is not sending the updated FS image to the what you say, the name node, right? So whatever new changes are coming in, for the name node, right, it is keeping a track of it and it is writing it in the edit log, and ultimately that will be in the secondary name node, right, and it will be merged with the like previous, or let's say previously latest FS image, and new one will be generated, right? So that's how it will kept on working. And as soon as, let's say, by any reason name node goes down, in that case it will when we are rebooting our name node, it will get the like the late or the last, you can say, the updated FS image from the secondary name node, and it will start its processing from their point onwards.
Okay, so checkpointing means
You can-
just having an updated FS image file and not going in the safe mode.
yeah, correct.
So the other doubt is that if this is happening, so I read it in a blog that the edit log file is stored in RAM, whereas the FS image is stored in disk. So if suppose the cluster is kind of a very busy cluster, and a lot of operations are taking place, and so in that case the edit log file can increase to a very can become a very big file, and storing such a big file in RAM can be kind of a very tough task. So
Yeah,
how
so that,
exactly?
in that case it can be tuned in terms of the that merging part happens, right? So these are the things which are parametrically configurable. I do remember my experience with Apache Flink as well, where we keep on doing the checkpointing of our state data, right? So for that one, whenever you have the doubt, if you have, let's say, you are doing checkpointing after, let's say, 5 minutes, so obviously during the 5 minutes window, the in-memory data would be quite big enough, right? And right, it won't be able to get fit into that one. So you can minimize the that compaction time, right, or that merging time window. Let's say earlier it was happening in 1 minute, like edit till 1 minute, everything will be written in the edit log, and then it will be merged with the FS image. It can be reduced to, let's say, 10 seconds or 5 seconds, so that minimalistic edit logs are getting written into it, which can fit in your RAM, right? And then it is continuously getting merged with the FS image. So that is another way it can be solved. Or other, well, let's say, obviously, like increasing the RAM or the in-memory part is not always the option, right? So if you have a decent amount of memory, and you know the like how frequently those edits are, or the metadata you are going to read in your name nodes, so on those things also this part will be done. But I think first option is something which is much more feasible for this kind of thing, mostly taken care by.
Okay, so so if we are like you told about the edit log that we can just reduce the check time for the
Time window,
checkpoint. Yeah, so if we are reducing the time window, that means that we will be clearing the edit log completely. Then in case we are clearing the edit log, then like to reboot the entire system, we will need the new FS image. So I mean,
that
the
that
reboot
would be
is taking
needed. So see, this is something, right, which is more from the you can say again a metadata perspective or processing perspective related changes. So even if, let's say, earlier the time was set to 1 minute and now you are trying to reduce it to 20 seconds or anything, so obviously sort of reboot will be required. And in that case, right, so whenever I am talking about my practical experiences, where whenever we do these kind of reboots in the production, we don't do it instantly, right, without any notification or without any communication. So how things actually work in the companies, so we will be having so I'm taking my experience from the Paytm and other orgs as well. So in Paytm we had a dedicated Hadoop admin team which was completely monitoring and taking care of that Hadoop cluster. So by any time they feel that there is any need of upgrade which is required for the Hadoop cluster, or space cleanup is required, and they need a downtime for it. So for that one, 2 days before, they will start sending the communication to all the users which are onboarded onto the Hadoop platform, right, or who are using the Hadoop cluster. So you will start getting notifications till 2 days, so that you can take care of all those jobs which you have scheduled, right, and you can probably stop it for that duration where the maintenance is getting happened and the reboot will come into the picture. So that is how gracefully things will be done, Mansi, in the production. It will never be like instantly without any notification and communication. You have shut it down your Hadoop cluster and rebooting itself, so that you have decent checkpointing. Things are not getting updated on the fly, and you are able to do your reboot gracefully. So that's how things work in production.
Okay. Thank you, Shashank. And one more thing, reading about Hive, I came to know that Hive takes something. It was like schema on read. I
Yes,
read
schema on
something.
read,
So
correct.
can you just elaborate this thing?
Yeah, so schema on read, there are two terminologies, schema on read and schema on write. So schema on read is a terminology is being used where we will have the data already, and on top of that we are applying our schema and trying to read and query the data. So that kind of processing is somehow known as the schema on read. So here, understand this thing. So let's say in your HDFS, data was already there, and in Hive we have a concept of external table. So in the Hive console, we created our table without even knowing that how many columns, let's say how many columns are there and what is the type of the each column there. By assumption, we created any table. And what will happen when we created our external table, and when we are trying to read the data, that time what will happen when we are trying to read the data, only that duration validation will be happening, whether this data is getting matched with the schema which we have imposed or not, right? So this validation is happening on the read time. So wherever we will be having this kind of use cases, you should call it as a schema on read. And now let's talk about the schema write kind of operation. So let's take an example of transactional database MySQL. So there, what happens, we create our table schema, correct? Our table is created, all the integrity constraints we have applied. Now we try to do the insert operation. So let's say any record you are trying to insert and it is not matching the schema data type or the integrity constraints, your validation is getting failed during the write time itself. Okay, so this is the difference between schema on read and schema on write.
Thank you so much, Shashank.
Cool. Next in the queue, Shripad. Please go ahead.
Hi, Shashank.
Hey.
First of all, thanks for your in-detail explanation. So I have two theoretical questions and one practical question. So related to CLI. So first I will ask the theoretical question. So first of all, I came across, like you said that Hive can be, Hive is comparable to a execution engine kind of thing. So I'm actually a working professional as a BI developer. So usually I have a task of migrating the whatever data is there to the tabular cubes. So there the client like gives a terminology called Hive tables. So I am having a confusion. What is the use of, what is the relation between Spark and Hive? So I will be using the Spark programming. So I wanted to just clarify with you. So how the Spark and Hive are related and how they're.
So individually, these are two different frameworks. Again, Hive, right? It can do its own responsibility. It can serve its own responsibility and process the data, analytical queries. Same thing you can do with the Spark as well. Apache Spark is also a distributed computation engine, which can do batch processing as well, and which can do near real-time data processing as well. Okay. So Hive is more sort of data warehousing service, as I said in the beginning as well. So you can have things in the similar form, right? So when we talk about the Spark, right? So in the Spark, we have a functionality of Spark SQL, but Spark is a computation engine. It will only compute, right? It will not store anything in it, correct? Whereas the Hive is a data warehousing service as well. So it can point to the external tables as well. It can even, we can even create the managed or the internal tables in the Hive and can dump data into it and then start executing, correct? So Hive can maintain that kind of data as well, but whereas Spark will not be doing it. And these two things can work together as well, because we talked about the metadata storage of the Hive tables as well. So somehow if that metadata part is exposed or not, let's say that is not exposed from my Spark application, I can make direct connection to the Hive and I can directly point to any Hive table from my Spark application as well. So the way you read CSV files as a data frame in your Spark application, since Hive tables are also pretty much structured in terms of the rows and columns, same kind of data frame you can create if you make a connection to Hive and point your data frame to read any specific table. So that's how these two things are related with each other.
Okay, Shashank, coming to my second like a question. So, our RDD is in the Spark similar to the reducer, or what is the like a difference?
No. So reducer is technically a completely different thing, like doing all the aggregation and all. So RDD is just a part of Spark, right? And it's a basic abstraction, or you can say a data structure specifically made in Spark to hold the data. It can be the actual data which you have read or any intermediate data you have processed. So that is how it is different.
Okay, Shashank. So coming to my like a command line question. So whenever I start the Hive, so I am like asked to switch to the safe mode actually. So as you told in the session, so I started typing the Hive in the command line. So initially I got an exception, like a dump, stating that your this
Yeah.
is in the safe mode. So I had to manually like use a command to turn it off. So is there any other better way? So or else it will be like that.
Yeah, in the local, this is this is a kind of challenge, but did you try it from Hue as well? I guess from CLI sometimes, yes, we face this kind of challenge, right? But when it comes to right, that thing, what do you say, the Hue and all these things, we won't be facing those challenges.
Okay. So, and this is question related to last session. So, when we try to use the FSK command, right? So, the Hadoop FSK command. So, like I came across one stat saying that two files or two blocks were corrupt. So, how should we like understand that, and how should we rectify that? So, in the HDFS environment. So, if at
So,
all.
what did you say? Like, why your blocks were corrupted?
Yeah, so when I used a HDFS FSK command, like it displayed the status, health status of my Hadoop actually. So in that HDFS, so I got a message that two blocks were corrupt actually. So I couldn't proceed further. So how to rectify that was my question actually.
So corrupt blocks, right? Yeah, I mean that is something, right, which so health status is something which you can monitor from the UI itself. Let's say that Ambari and all, right? So there you can check the status and the node data or data which is stored in the data nodes, but specific to the block, whether it is corrupted or something, I'm pretty sure that is something which you can get during the runtime itself to figure out, right? And when let's say you are processing anything, you are trying to run your job, then you might get also information on, let's say, the yarn log. Let's say you fired the Spark query, right, or the Hive query or MapReduce job, it will go to yarn as well. So there you can open the yarn logs as well, where the logs for each containers, right, will be written on. So you can probably check there that is there any data related issue in that particular blog, or what is the prime reason to that's why it got corrupted. So that's how you can figure out individually beforehand without even running and executing it. I don't think there is any way to figure out that why it is corrupted.
Okay, thanks, Shashank, for your like explanation. You patiently explained all the questions. So thanks once again. That's it.
All right. So next in the queue, Vinod. Hello, Vinod.
Hello, sir.
Yeah.
Your lectures were meticulous and you were trying to explain everything in detail. my first question is, when I put in the query through the HQL, how long it will take to process all the things and get me the results I want? Like, what will be the duration for it?
Yeah. So this is something which will always depend on the data, right, which you are going to query. And even let's say moving forward, when we will talk about the partitioning and bucketing kind of concepts, right? So there will be also a concept that whether you are performing your data on a selected, whether you are performing your operation on a selected data or not, right? So let's say you have a 1 terabyte of data stored in HDFS and you have created a table on top of it, right? And you are trying to do any kind of aggregation queries. So even it can take hours, more than 5 hours, 6, 7 hours, right? I have experienced these kind of things in Paytm. So on Paytm, right, in 2019, when I part of Paytm, what was happening, obviously on daily basis, we were getting hundreds of millions of transactions, right, related to the payments and all. And that data in size ultimately becomes in the terabytes. So morning 7 or 8 a.m. we had a scheduled job which start getting executed for the previous day's payment data, and by afternoon it was like about to get finished because we had to read the entire data. So whenever you will be scanning the whole data and performing complex aggregation operations like joining, group by, reduce by, and all these things, obviously the runtime would be much higher. But instead of that, let's say, if your operations are supposed to be worked on a specific set of data, then it's always best to basically use the partition keys in whereby clause so that you can work on the selective part.
Yes, sir. Thank you. Then the second question is, all the HDFS storage and the MySQL, is it depends upon the organization to have it in the private cloud or public cloud or in the hybrid, or can you explain?
It will depend on the organization, that what kind of system they are preferring and what kind of, how much amount they can invest, right, in this kind of infrastructure.
Yes, sir. Yes, sir. Thank you so much.
Cool. Now next from Kundan. So it's 2 p.m. To 8 p.m. guys. So we'll have it continue till 2:30. So yep, by that time, feel free to ask your question. Hey Kundan.
My question is regarding JDBC plus ODBC.
Hey Kundan, I can't hear you properly.
My question is sorry. My question is regarding JDBC.
Hello. Your voice is breaking. I can barely hear you. Not sure it is same for others as well, but I'm not able to hear you.
My question is regarding JDBC.
Okay. Yeah.
You said that JDBC is JDBC line of code that we incorporate in our Python program, Java code to connect with the Hive.
Yeah. So this is something which you don't need to write, right? So for different kind of databases, different kind of connectors are already there. Like this is something like a packaged jar or something like you can say, which is already created compatible to their individual databases. You just need to download it, and let's say the directory from where you are executing your code, that JDBC connector should be present in that directory, and you need to mention a path for that one, that which JDBC connector you are going to use, and in the program it will automatically get picked.
Okay. And my second question is regarding flat map. Can you repeat what is flat map?
So flat map is nothing, just like a simple kind of transformation. It was just to give you the example, but yeah, I will explain more in when we will be discussing about this part. So it is a kind of transformation which generates one to many kind of which okay, sorry, what it actually do, it basically creates a one to many kind of operation, one to many kind of output, right? So let's say we passed one line to it, right, and we had a split operation or something like that. So line was one single output, and after doing the split and passing it to the flat map, we got multiple words. So one line got divided into other outputs, right? Or other words. So one to many something kind of output got generated. So in the mapping, what happens, we will be having direct one-to-one map, simple, let's say whatever you have provided, right? Only corresponding to that output will got generated from one value, not multiple values get generated. So that's the typical difference between flat map and map. But practically, we will discuss more when we will be studying about the Spark. So in this one, I just used it to explain in terms of the example.
One more question. Since the HDFS is based on the principle of write once and read many.
Yeah.
So when Hive is interacting with the HDFS, it is just taking up tables from there. There's so many tables. It has to do join operation between those tables. After that, some intermediate results get generated. After that, some final results get generated. So, I mean, how it will write those things into HDFS?
Kundan, I'm not able to hear the second part which you have talked about. Not sure, maybe the issue with voice or what is that? I'm not able to hear you.
No, I'm saying that it is based on the principle of write once and read many, right? So, I mean, if you can read many times data from HDFS, and but it will, I mean, where the final result will be.
I couldn't understand the last part. So Kundan, can you write down your text? Write it down in the text because your voice is breaking. I do understand the first part where you talked about write once and read many times, but the end part I'm completely not able to get. So it would be better if you can write it.
Okay. Thank you.
Yeah. Okay, so next question from Parvinder. Please, Parvinder, go ahead.
Thank you so much, Shashank, for giving me this opportunity, and thank you so much for today's class. I'm doing this course because of you, because prior to this, I have only heard about these terms. I have no idea about what is data engineering all about. And I've started following your YouTube channel. And from there, I got the inspiration. This, yes, people like me can also explore and contribute in data engineering field. So thank you so much for that. And I had a lot of questions, but most of the questions were asked by the our peers. And my first question is one is suggestion that I would like to give, that we don't give a proper service from our a doubt clearing session that is happen 6 to 12 every day. So we are not getting proper support there. So I think we need to improve that particular space. If you can share this feedback with the entire team, then it would really help and make our experience good. And yeah, and the next thing, what I understood by that driver is when it receives any HQL query, then it create a session, as you have mentioned. So I think it works more or less like a RAM. So whenever that execution is happening, program is still there in that session, and once it is over, that session got vanished. Is that correct?
Yeah, so it's not like don't connect it with RAM. It's just treat it like a master which is running multiple daemon services or threads for multiple sessions which are getting created on the Hive engine for multiple queries, and it will take care of its syntax check and managing the metadata for that particular query and for that particular session in order to get it accomplished, right? So that is how it is. It is nothing. It has no relation with that RAM sort of stuff.
Okay. And my last question is, as Sudhanshu sir and you have mentioned that we are going to have a lab kind of thing, that I have a little constraint because of on a financial front. I'm using the office laptop right now, and buying another laptop immediately is not possible for me right now. So I wanted to understand that by when we can have that lab, so that I can use the same laptop to do a practice and everything practically. Theoretically I am understanding, but practically till the time we will not do there is no, I think there's no point.
Yep. So this will be a Teachers' Day gift, right, from our side. So don't worry. That's how we were planning it. So yesterday, right, it was 2 a.m. Right, I and Sudhanshu were working on it, finalizing all the things. So it is almost there. Just integration for the course perspective. By next week, I'm pretty much hopeful that next week, whatever class we will be doing, it will be on the lab environment.
Thank you so much, and I would be really grateful to you and Sudhanshu sir. Thank you so much, Shashank. Thank you.
Cool. Next question from not able to pronounce the name.
Just a second, sorry.
How should I pronounce your name?
Can call me Hisham.
Okay.
Actually, I just have a small doubt. Like you were saying, syntax and semantics check. So I am confused about semantics check. What is it actually? Semantics.
Okay. Yeah. Cool. That's a good question. So semantics check, something like. So let's say there is a keyword. So select from. Okay. So keyword specific check is a syntax check. Let's say if I somehow write from to, let's say, ROMF, something like that. Okay. So this is a syntax check particularly. So semantics check is basically the way it has been written, the sequencing and all this part, because sometimes, let's say, even if we talk about the English, right, the English grammar and sentences. So some sentences, even if we replace few words here and there, right, still they sound fine. I mean, right, you won't, like, minor differences you won't be able to find out until unless your grammar and other things are quite good, correct? So that is the main thing, where, let's say, select a star from, if I, let's say, write it from star select or something, right, like that. So that is a kind of semantics check. But prior to that, let's say anything related to, if we are doing wrong with the keywords, right, keyword, let's say from, select, group by, we forgot mentioning by, this thing, that is specific related to the syntax check.
Okay. And one more thing, like you were saying about that reduce. Someone was asking, you were sharing the screen and just mentioning about that reduce. You mentioned like 0 to 10 and 10 to 20 that reduce while discussing. So is it like predefined, or
Yeah, so
how is it?
it is not something which we will define. It is all will be taken care by the framework itself, backend implementation. But since I have seen, I haven't practically coded it, honestly. But whatever understandings we have, because see, map reduce coding is something which has completely been, not completely, but most of the organizations shifted to Hive, Spark, and all these things back in 2016, 17 itself, right? So the map reduce coding is typically this partition, like the custom partitioner, right? And well, you can say the custom combiner. This is something which can be coded in typical map reduce code as well, right? So how your hash will be generated and all these things, that can be coded, right, if you dig too much into the map reduce coding and the optimizations perspective. But ultimately, the, let's say, the how particular key should generate what kind of hash value and where it should go, it will be taken care by the framework itself. Like, we won't be deciding the range for the reducers.
Also, the number of reducers will be defined by the framework, right?
Yeah, by default it will be like the number of, let's say, processing it is doing, it will be defined. But reducer is something which also can be taken care by us as well. Like, it can be configured that like, if in terms of the scalability and parallelism, if we want to increase something.
Yeah, okay. And one more thing, like you were saying that in the execution plans will be there will be like more than one execution plans, like E1, E2. So are we writing those codes? Like, are we
Oh, no, no.
writing?
So
Like
that is
how-
something, right? The Hive engine itself, those things are coded in Hive engine itself. So as soon as you fire normal, your worst query, right? The best execution plan, like engine will try its level best to pick up the best plan in terms of the cost, even for the worst queries, right? So that's how it will be. We will not code anything.
Okay, even that DAG part is done by the engine, right?
Engine, correct. Yes.
Okay. Okay. Thank you so much. That's it.
Cool. Next question from Laksh.
Hey, hi, Shashank. Thanks for the great session.
Hey.
Like the main intent of joining the big data course from Aniran side is to get the practical experience, right? And like I've been reading about the big data content over YouTube. The basic question that I have, like we are able to practice on the basis of toy data sets that we get. Like the example that we discussed about the word count, it is out there everywhere, right? Once we complete the section step by step, like completing the Hive part and further sections that we have, are we going to touch upon the industry level projects?
Yes, yes, definitely. So module by module, as we said, right? So the number of projects you will be working on, right? That is definitely a very, very big. So module by module, we are proceeding. So even on your dashboard, right? I think you might have started getting assignments and quizzes on the module by module that will kept on uploading. Okay, but moving forward, once we complete decent amount of modules, right, where you can actually work on industry related use cases, so we have all those things ready with us. We are just trying to complete the module so that you can work on those kind of practical projects. So that is sorted, right? You don't need to worry about that one.
Right, right. The way you explained about the situation that you face while working with Paytm, so those kind of situational case studies will be also discussed in the curriculum so that we can have detailed
we will try to give you the we will try to give you the best ideas. Let's say in the interview preparation part we have, right, where you will be getting the complete mock feel of the interviews, and even the projects you will be working on, right? It's not just you need to complete the code part, you need to come up with all the things. It's documentation, the presentation and everything, right? You need to done there. So there you will be mentioning the challenges you have faced and the future scope you will be including. So during that discussion, right, we will cover all those things, right? The challenges you have faced and how it can be taken care in the practical world. So that's how we have planned it.
Sure. So that will give us like an industry level of experience.
Exactly. Yes.
Thanks. Thanks.
Cool. Next, Resolve. Oh, I'm sorry if I have pronounced your name incorrectly. Please unmute yourself. Hello.
Yes, sir.
I can't hear you, man.
Can you hear me right now?
Yeah, I can hear you now. Yeah.
Actually, sir, I am new in this field, so some
Okay.
things are going over my head. Still, I am trying to like understand all the things. That's okay. Just I want to know that these two are two framework. Like Hive is one, another HDFS is in the below level.
Yeah, so HDFS is not a framework. HDFS is not a framework. So
This is storage,
initially, yeah, so far two things we have covered. Hadoop is one framework. Hive is one framework. Hive works on top of, let's say, the Hadoop related things.
Yes, sir.
Hadoop had three parts: HDFS, MapReduce, and HDFS, MapReduce, and the YARN. So HDFS is basically for the distributed storage part. We stored things there.
So I just want to know that this Hive has a client interface and how it's connect with the HDFS architecture, Hadoop architecture.
So that is something, right? That is so see, if you configure Hadoop and Hive by your own, so all these things you need to mention in the configuration files itself, right? Okay. When you install Hive, you need to mention those HDFS location, which this framework will keep on using, right? So that's how it will be. But since the way the environment we are using, everything is pretty much installed there for you, So it will be taken care of. You don't need to worry. And ultimately it is working fine with the HDFS part. But yeah,
So
if
just
you
I want to know
completely want to understand it,
that
so during the
information, metadata
configuration, this will be
information,
taken care.
which is available in the name node, that is collected by Hive or what, or Hive directly control?
Sorry?
Like
The
metadata MFS image or metadata information, I can say, available in the name node of Hadoop HDFS. How this Hive is collecting this data from name node, or
so Hive, so it is not connecting via name node and all, right? So Hive as a service, right, will be installed. Hive as a service will be installed to, you can say, Hadoop cluster, right? Wherever your Hadoop is installed, right? So there you can install the Hive. So since in the configurations, we have provided the name node locations, right? And the HDFS locations as well. So whatever we are firing, where let's say the blocks are stored in the data nodes, yes, definitely that request will go via the name node side, because Hive is installed, will be installed in the same cluster where the Hadoop is installed. We definitely need to do in that way. Without that one, it won't be doable.
okay, sir. Okay, thank you.
Cool. Next question from Revant.
Yeah, good afternoon, sir. Actually, I was planning to quit my job. Can you please say what is the course duration of this?
No, so why, can I, if you are comfortable to share the reason?
Actually, it was due to my manager, like whatever. I was actually in data engineering field itself. Whatever small mistakes I'm doing, she's pointing on completely on that. And due to that, I'm not being able to focus, and the work hours are being around from morning 10 to night 11:30, 12. It was being continuously doing like that only.
And which company is it, if you are comfortable to talk about?
It's CTS.
Hello?
Yeah, it's Cognizant.
Hello?
Yeah, I'm speaking. Am I audible?
I lost you for lasted 15 seconds. So
Yeah, it's like a Cognizant.
Cognizant. Oh, okay,
Yeah.
I see. So see, I can understand, right? This is something has happened to me as well, right? Doing good things, but manager is not recognizing it, or the team is not recognizing it. So this is everywhere, right? But I see, I know, and nobody can even enjoy that negative environment and other things, but I can share I can talk about it, and then I will leave it up to you whether you feel comfortable to quit or not. So the course duration is something, even after 3-4 months, right? We will be in a good position where we would have covered Hadoop, Hive, SQL, Cassandra, Kafka, and Spark, and it would be good enough for you at least to where like you can ask us to push your resume for the openings or like whatever we have the tie-ups, right? We can manage somehow the timings and all. Then it's better to do in that way, so that at least mentally you are not going in that thought direction that you are like jobless at this moment and you are just taking up the course and like learning something. So these are the two aspects, right? Whatever you are thinking at this moment, maybe it is because of the impulsion, the wrong things being done by the manager, but uh, like accordingly you need to handle the situation, because this is not just at one place. Even moving forward in the next phases of your life, you will definitely meet such type of colleagues and companions where you will face this kind of situation. And everywhere, not in a impulsion, you shouldn't take this kind of job quitting kind of decisions, because yeah, this is a big decision in itself. So once your plan B is ready, when your backup and everything is ready, at least in, or you are in a good state, or you are confident that you will get completed, then just put down the paper instantly. That would be my advice.
Okay, sir. Thank you. Then another thing, will the things like creating pipelines for Netflix, Uber, like this, those interview questions will be there now. Those all will be also discussed, right?
Yeah. So the interview prep, it will be like design related things will be there.
Yeah. Okay, sir. Thank you.
Next question from Devendra. Please go ahead. Devendra, are you there? All right, let's move to Kushagra. And guys, let's be quick. So we are almost reaching, we have crossed 2:30. So let's be quick with the questions and quick with the answers as well. Please go ahead, Kushagra.
That I have is like, yeah, that while mapping, like
hello,
what will happen if the data is like hi, hello, bad, hello? So if we have two hellos in a data, so will it be like hello to
yeah, so
sort of?
yeah, so
Will it
it
be
will
like
not,
that? Or?
yeah, it will not be hello 2, it will be hello 1 time, hello 1 another time. So these two key value pairs will be generated by the map function and will be pushed as an intermediate output. After that, collecting all the ones together and summing it up will be done by the reducer itself.
Sorry, your voice is breaking a bit. Can you please pardon me?
Am I audible now perfectly? Hello?
Yeah.
Yeah, so what I was saying, so two things will be generated, means two values like high, comma 1, high, comma, like 2 times it will be generated. It won't be high, comma 2, because in the mapping phase, we are doing simple mapping, no summation, no aggregation, nothing like that.
Okay. Yeah, got it.
Yeah. Next question from Mahantesh.
So the next, yeah, hello.
Yeah, please go ahead, Kushagra. I thought you were done. Sorry.
Hello. Yeah. So as soon my next question is like as soon as data comes in and a session is generated, so is there any sequence like in which the driver works? Like first, they like planner works, then execution, then optimizer, or something like that. Is it a specific sequence that it works on, or how's it?
No. So driver will not be taking care of this thing. So this sequencing, scheduling, and putting the queries into the queue, all these things will be taken care by the resource manager, which is Jan here, right?
Okay.
So that is the responsibility of the resource manager. Driver will just try to keep open that session and having that executional metadata in place, right? It won't be taking care of the sequencing part.
Okay. Got you. One last question that I have is like this. Can you please explain a bit about this CLI and like why do we only use JDBC or ODBC for thrift? This is the last question that I have.
So that I talked about these different three things, right? So CLI is, let's say you have your Linux terminal, right? So in your Cloudera environment, when you will open the Linux box and type Hive there and enter, so that CLI means where you are writing command right in front of you and on the fly, right? And trying to communicate with the Hive, doing the queries and all these things. That is the CLI part. And we're talking about the JDBC. Let's say you have a Python application, Java application, or any sort of application. And from the program itself, you want to connect to the Hive and want to do something, then you need those JDBC connectors, right? In order to make a connection to this kind of data warehousings and other databases as well, right? Third is the web interface. So the best example is Hive, right? In the Cloudera environment, it is a web UI. You simply put your username and credential there, login, and a simple, neat and clean web interface is prepared for you. There in the graphical user interface, you can see the list of databases, list of tables, which has already been created, and everything is pretty much sorted for you. So these are the multiple ways to interact with the Hive.
Yeah. Thank you. Got it. Yeah. Thank you. Thank you.
Yeah. Hi, Shashank. Mantesh here. Can you able to hear me?
Yeah, I can hear you. Please go
Yeah,
ahead.
Shashank, thank you for the classes. This is nice talking to you. So I have two questions actually. One is just related to just a suggestion. See how almost like I have a 10 years of experience working in a data industry only, more on a SAP side. But like from the beginning, I'm working on, you might be knowing ETL tools. I have touched most of the ETL tools,
Yeah.
boards, ISCS, anything.
Informatica and all.
Yeah, everything I have touched. I think more than 35 certifications I have. But
Amazing.
my question is actually, if I want to see, usually the industry needs a hands-on. Like although I can clear the interview, everything is there. But how I can make interview that I can able to do anything. So that's what my question. That first question. And second is, you might be knowing Snowflake.
Yeah.
How competitive because we are using. I'm also working in a product-based industry. How Snowflake and Hadoop interrelated actually, or how it is competent? Because I didn't see anywhere people are what to say the comparing these two. But I feel Snowflake is
So
very good actually.
yeah, I will explain it. So talking about the first part, right? So how you can crack those interviews in terms of all those things. So at least at your experience level, my suggestion would be focusing more on the practicals plus more even on top of that, the designing aspect, right? So 10 years of experience, the things which will be expected from your side in the interview, that how good you are in the designing part. And since you have a good experience in the ETL and warehousing, so one of the interview round which is very important, and it could be your third round and fourth round, the data modeling or the data warehouse design. So from the highly experienced candidate, this is the very crucial point where they want you to perform really well, the designing rounds, right? So that would be my suggestion to you. Whenever we will be moving ahead with the industry level projects, make sure you complete it by end to end, understand it, everything, try to even come up with the alternate approaches as well, right? That's how you will enhance your design skills as well for the data pipelining and all. Now talking about the second part, the Snowflake on and other things. So see, every now and then we know technology is getting changed, right? New things will keep coming and right, keep including in the tech stack. But the fact we need to understand is that how feasible that particular solution can be for the organizations, right? Let's say the big tech firms or the established companies can have that enterprise Snowflake tool for their use cases, whereas let's say service based companies or small startups or any other fast based product based company, anything like that, they are not confident enough to move ahead with the Snowflake. And with these kind of companies, they have a culture of making things in-house as well. The best example is Uber as well. Like they have created so many amazing frameworks, right, in-house, and now they are working as an open source tech stack as well. LinkedIn is a good example for that, right? So we should always put our hands on the ground where these things are aligned, right? Because Hadoop, HDFS, and all these things will never go away. That was the base, and it will always be the base of every single company, because whatever other open source tech stack they are using, the base is Hadoop, HDFS, Yarn, and all these things. So yeah, Snowflake is here. It will definitely get hype, and people will try to move into it. Companies will be using it, and it can be a good solution, right, for multiple use cases. But when it comes to design a solution and feasibility, we always need to think from the company perspective that how much cost we can involve into it. So the thing, let's say we can achieve from the Hadoop, HDFS as an open source tech stack, maybe we need to add 3 times, 4 times, 5 times cost into Snowflake solution. So that's how it is. Functionality wise, definitely Snowflake could be, let's say, 100x or 10x better than HDFS. But in terms of the feasibility of solution or the kind of use case we are solving, that will be also dependent.
So after I finish this, right, like maybe can I add the skill sets as Hadoop, these things also? Because as of now, I mostly deal with no, actually every company has different tools, HANA, this, that in memory. Every company is coming with some or another tool, so no, to
Yeah,
cater the data
that's why I'm
problem.
saying
Yeah.
not anybody can learn
True.
all of the
All
tech
the things,
stacks and
correct.
all, correct? So as
True,
soon
true.
as once you are in the industry, right, you even get a exposure on at least 50% of the standard used tech stack, right? You are completely safe in terms of the interviews and getting job opportunities, because everybody knows whatever new is coming, it will keep on evolving, it will keep on coming, and it will keep on going away.
Correct, correct. Like for example, I working on a HANA more than a Hadoop and all. If something comes with a HANA, I can crack it very easily.
Correct.
But this Hadoop and all, I may be having only the theoretical knowledge more, but the confidence which gives after doing a practical things is different, and theoretical things is different, right?
Yes,
So it's easier to crack those things, and even the interviews are coming on that side only more than a Hadoop and all. Yeah, thank you, nice talking to you.
Same here.
Yeah, thank you, bye.
Cool. Next from Shekhar. Guys, let's be quick. Like I'll just spend next 4 minutes and 2:45 we'll end up. I know you guys need to go for a lunch and all, because we have tomorrow session as well. We will cover rest of the things tomorrow, not to worry. Quickly, Shekhar.
Yeah. Hi, Shashank. Thanks for the great session. Just have a simple doubt. As you told that the tables and actual data, everything will be stored in the HDFS itself. So my doubt is like, how are these tables created? Like, for example, if we get like 1 TB of data and all, those must not be stored in the tables directly, right?
No, it will be because see, the way Hive is working, so there are two ways. One is the internal table or the managed table, we say, right? And another way is the external table. So in external table, what will happen? On the Hive engine, we will only create the table definition, that how the structure will look like. But the actual data will be residing on some remote HDFS location, right? That is the about this external part. Now, when we talk about the managed table as well, so just simple take an example of MySQL, right? When you create tables there, you load data. So MySQL, wherever it is installed, it will occupy all that space to insert or to store the data which is getting inserted into the table. So similarly, since Hive is using underlying HDFS layer as its warehouse storage, so whatever table we have created, that means the internal tables, and we are trying to dump the data into it. So ultimately, it will flow through the processing engines and will go to the underlying HDFS layer, which is being used by Hive as a warehouse storage for itself.
Okay, that means like the data that we are going to dump, that will always be stored in form of tables, right? In HDFS as well.
Yes.
Just one more quick thing. So we are talking about like creating jobs or scheduling jobs, right? So what exactly are these jobs? Are these map reduce jobs or
not map reduce? So simply, let's say you have written a big HQL, right? Let's say at least 50 lines of logic which you have written in SQL using multiple tables and complex things, right? So this is also one job for you, one piece of code for you, right? Which you can schedule somewhere using Airflow, Uzi, or anything. And once that cron time is hit, that job will be directly fired, right, to the particular Hive or wherever you are trying to execute it, right? Or if it's a Spark, then again your Hadoop cluster, and even if it's a Hive job, it will be executing ultimately on Hadoop cluster, and resources will be allocated by Yarn and all these things. So that is how it will be. Means whatever you are writing, right, in terms of the computation and calculating, that is a job, right? Don't relate it with a map reduce job. So job is a very common terminology which we will keep on using for everything which we write.
So once we shoot any query in Hive, so basically a map reduce program will be executed, or right?
Yes.
Okay, yeah, that's it, Shashank. Yeah, thanks a lot.
Cool. Next, Jayalal, please go ahead.
Yeah, hi Shashank sir. So see, basically for this MapReduce framework, I have one question, because whenever there, if the resources are used from two different data node, okay, for creating a container, right? So will that job executed totally in each, execute locally in each node, or if yes, will that resource gets, released after completing each task?
Yes, yes. Obviously, see, if resources are not getting released, then how you will execute other job? So this is answer for your second question. Second, so so what if that in the beginning, right, I emphasized on one thing multiple times, that in distributed computation we are sending our code to the data, and data is stored on the data node. So this code which is our mapper function will flow from the clients and from systems to the data nodes, and the task will get created there. So whatever physical data in terms of the block is stored in that particular node, the execution will be happening only on that part, and that will be known as an intermediate output. Similar type of map functions will be running on different data nodes. So different intermediate outputs got created, and at the end everything will be combined with the help of the reducers. So that's how it process.
Here in this case, for example, we have different, node manager will be there, and that node manager only will be creating the container, right? And is that correct?
Not node manager, not sorry, not node manager. It will be like the yarn is something, right, which will ask for the resources on the cluster, right? Who is the master? Correct. Yeah.
So this is yarn child container, YCC, something like that I read somewhere, because I am also very new to this technology. So this yarn child container will be created. There only the task will be actually getting executed, right?
Yes.
So assume that we have 2 or 3 nodes, and wherever, multiple jobs will be submitted from edge node, and this nodes will be keep on getting busy, right, each time. So assume that we have data in data node 1 and data node 2. There, okay, data is there, but there is no resource there, because we need CPU, memory, and CPU and memory, right? That is the process. Mainly that resources. If the resources is not there in data node 1 and 2, but we have data node 3 and 4, there we have resources. So, but data is not there. Partition data is not available in the 3 and 4 data node. So in that case, how this framework will be handling that situation?
Yeah, so see, in that case, see, it's not for any job, right? Wherever, let's say, your data is there, so right, your containers will be, so containers is something which will keep on creating on multiple data nodes as well, right? So since name node, the blocks are actually stored, correct? So even if the containers get spinned up in different data node, and for that particular job, the data was supposed to get, it was not present on that node where container spawned, correct? So in that case, with the help of the metadata information via name node, containers can point to those data nodes where the data is actually stored, and can get it for the processing part. So that's how it will be done, because see, it shouldn't be like that until and unless on that particular node, if the resources are not available, I will not start executing my job, right? That will be the not good utilization of the resources available. Okay, so as soon as you get a resource, spin up the container, you have the metadata information, point to your data blocks, and start the execution part. Just pull it in the container itself.
Okay, thanks, sir. Thanks for, because I just don't want to prolong it, because you're also very hungry, even we are also, right? So I'll write some other things, and maybe on one-to-one mentorship that which is getting provided. So I'll be just writing an email. If you get a chance, please look and reply, please. Thanks.
Sure, please.
Thank you.
Yep. Priyank, please go ahead quickly.
For me, the question is that on the reducer part, suppose after map, we are getting the key value combination is very less, but one particular key is having a lot of data. In that case, if reducer is working on it, then it will take a lot of time. So can we reduce this particular time?
Yeah, data skewness. So your question is actually related to the data skewness. So in that case, what is happening, the way hash keys were getting generated, so for most of the keys, right, let's say you are getting same hash key, correct? So in that case, lots of data will be going to the one particular reducers, and other reducers will receive less amount of data. Correct?
Right.
So this is something in order to deal with these kind of situations, right? So either the way is to play around those key columns which you are going to use for the execution. So in Spark, this is also one of the issues, and we have a one technique there where what we try to do, we try to randomize all such kind of keys so that even distribution of data can happen over different executors. But in the MapReduce code, if this is the case, you found this kind of issues while debugging it, you need to write some custom partitioner. So custom partitioner code will be needed there, so that what is happening, you are distributing, or in your reducers, data is actually going in the even manner.
Okay.
Yeah.
Thank you.
Okay, next question from Ronak.
Hi, sir.
Hey.
I'm currently working as in big data project. So when we get data and we extract and process it through PySpark, and after loading, we do movement, and we do movement from Hive to like storage. So we get error like exception error as SDFS. So what does that mean inside? What is the process? Why
Yeah.
it's there?
So sometimes what the kind of error you will be getting, let's say the directory was already created, right? So wherever, let's say you are trying to write, so the file location, output location, you will try to provide. So make sure the directory is not present there. Sometimes you get error for that one, right? I have seen it, and mostly like you will receive the errors.
Also on like exporting as SDFS and get failed. So
yeah, so mostly it sometimes, right, the reasons which I have commonly faced, the directory related things, right? And we are trying to write on a same directory which has already been created, because HDFS always try to create a new directory, right? Wherever you are trying to write. So that is the very commonly faced challenge in terms of the writing anything to HDFS. Other than that, if you get something probably then we need to look into it, that kind of error you are getting, then probably I can provide best answers. Maybe next time, let's say you do it something like that, take a note of or take a screenshot of that particular error or send it to me, then I can look into it more, that what is the reason you are getting this kind of error.
Okay, sir.
Yeah.
Thank you.
Cool. So last question from Devendra. Can you, or you already asked your question? Devendra? Not sure. I unmuted him twice, but seems like not working. But anyways, we are done for today's session. So guys, today, that's why I dedicated this whole session to resolve your minor doubts related to map, reduce, and all those architecture related things. So I am hoping tomorrow we will directly start from the practical part. Make sure you are ready with your Cloudera setup, and try to just type Hive on the terminal and see that Hive shell is working for you or not. You are ready with your FileZilla things to copy the files and everything. So tomorrow by starting 10 a.m. we will quickly start with the practical parts like creating databases and how to load the data, creating internal tables, external tables, and many other cool stuff. So we will be moving a little bit faster tomorrow, but yeah, I'll make sure that doubts and other things are clarified. So that would be expected. And can you just let me know in the chat box so you are sorted with your all your doubts related to map, reduce, Hive, whatever architecture, whatever even it is, let me know just in the chat box so that we can smoothly move from tomorrow onwards. All right, cool. All right then. All right. Nice talking to you all. Cool. What good your but many dots needs to be connected with self-study. Yep, self-study is something. Yes, it will be required. So whatever we have discussed, whatever doubts I have clarified, and still minor is something. So you also need to put your some efforts, right, in order to get it checked, right? So just do that, and we will be having more sessions, right? If you still something is stuck. Cool. All right. So see you tomorrow, guys. Wonderful. And this recording will be available, right? So don't worry. Whatever we have discussed, a recording will be there, and you can reiterate over it. All right. Bye-bye, guys.